What is up, guys? Fahir here from AwesomeTudes.com. And before we proceed to create our game, let us take a short preview. What is the game that we're going to create? So if I hit the play button here, we have a simple main menu with some animations and a play button. Nothing too fancy, but hey, you know me, I need to add some menus in the game and show how you can navigate from one menu to another menu because, well, people are always confused about that. So here we can only click on the play button. It will take us right away in the gameplay. When we jump, we hear some sound. So I am gonna turn on or turn off my volume a little bit. You see some obstacles that we have here, and we need to avoid those obstacles, such as the ninja or the squirrel that you just saw. We can kill all of these enemies while we are in the air. So while we are in the air, we are able to kill all the enemies. But if we are standing like this right here, they can kill us, as you just saw. When we die, we preview here the high score or the height that we reached. We can click again to play our game again, or we can, well, click on the main menu to go back to the main menu. So nothing too fancy, but hey, we will see a lot of cool features such as this right here. For example, the camera is not moving at all. If I select the main camera, you will see that the position of the main camera is at y equals 0. So we're not moving the main camera at all. We are moving the actual backgrounds and whatnot, and moving the enemies and all of those cool stuff we are gonna see. So let's get into it and create this cool game. I'm gonna go in another Unity editor that I have created, and we are gonna import the assets. This is, by the way, a 2D project. So when you create a new project, you're gonna select that 2D checkbox or radio button, not the 3D one. Name your project and store it wherever you want. So first things first, here are the assets. By the way, these assets, you can download them. Link is in the description below. So you will see something like, want to use the assets for this tutorial and the complete project. You can get it on the link below. So click on the link and it will take you where you can download these assets. So simply select all of these folders. So we have buttons and or backgrounds and buttons, enemies and obstacles, player, and the sounds. So I'm going to select all of these folders and simply drag and drop them right here in my Unity editor. And it is going to start importing all of those assets. Besides from importing the assets, we are going to create a main menu, or the main menu that you just saw in the preview in this video also. So I'm going to right click here and create a new folder. So again, it's right clicking here in the project tab. So right click, create a new folder. This is going to be our scenes. So not scene, but scenes. It's plural, not singular. And I'm going to save this scene by holding Command and pressing S. And it's going to open it here to save it, of course. Or you can go under File, Save Scenes, and bam, here you are. I'm going to select the Scenes folder, and this is going to be our main menu. So main menu, and I'm going to hit Enter. Now, what do we need for our main menu? Well, of course, we need a canvas and we need the background image. So I'm going to right click in the hierarchy tab right here. And by the way, if you want to rearrange how your Unity editor looks like, you can simply drag and drop all of these tabs. You can put them here. You can, I don't know, put them right here. You can make them float like this if you like it like that. I don't know which techniques you are using to, well, create your games, but this is how you can do it. And you can save the layout for, well, later reuse by going on the top right corner. Right here, you have the layout drop down list, and then you can click on the save layout and then simply name it here and click save, and voila, you're good to go. And I have saved mine as my layout, and if I click it again, bam, this is what I have. Let me just go here, click on the resolution. And by the way, I'm glad that this has happened because I see a lot of people have troubles with this. So I'm going to use the resolution 480 by 800 for this tutorial. Now, if you don't have it here, if I assume, and you need to go under Game tab. So Game tab is right here. If you don't have it, it's under Window, and then you can click on Game right here. And any tab that you see here, Animation, Animator, Console, Hierarchy, Inspector, they are all under Window, and here they are. So Scene tab, Game tab, Inspector, Hierarchy, Project, Animation, blah, blah, blah. So this is where you open these tabs. Now, regarding to the game tab, right below it, you have a drop-down list where you can select resolutions. Mine is, as I already said, 480 by 800. If you don't have it, you see this little plus circle right here at the bottom. You can click on that plus circle and it's going to open this pop-up window. The label here is the actual name for your resolution. So it can be full HD, for example. Here you have fixed resolution or aspect ratio. Aspect ratio is like 16 by 9, 16 by 10, but the fixed resolution is where you can write 480 by 800. And when you click OK, bam, here it is, full HD, 480, 800. These in parentheses is the actual resolution. And the first thing here is the name. I named this on 480 by 800. As you can see here in parentheses, that's the resolution. I'm going to click it back again to my 480 by 800 and I'm going to delete this full HD by right-clicking on it and clicking delete. And bam, this is how we do. So this is how we create these resolutions in Game tab. Moving forward, in the hierarchy, I'm going to right-click, go under UI and create an image. Now, before I proceed to do anything, I'm going to select the canvas, rename it to UI canvas. For the render mode, we have screen space overlay, screen space camera, and world space. I'm going to select screen space camera and attach the main camera, which is going to make this canvas obey the camera. As you can see, this whole thing right here, this big thing, this big rectangle is the canvas. But notice now, when I drag the main camera here for the render camera, bam, the canvas is right here where the camera is. If you want to know a little bit more about these and what they are, Unity Technologies has an official tutorial explaining what is the render mode for screen space overlay, screen space camera, and world space. Simply type Unity canvas render mode or canvas tutorial or something like that and you will find that video. And I also talk about this in my courses, so you can check those courses out. Below is the link to all of my courses. So I'm going to select screen space camera, as I already said. For the UI scale mode, I'm not going to select scale bit pixel size or constant pixel size. I'm going to select scale with screen size, and I'm going to set the resolution to be 480 by 800, the one that we are using. And here, screen match mode is going to be 0.5, so that the canvas and his UI children will match the width and the height equally. Now, taking this image, I'm going to put it in the middle of the screen. This is what we see here. And if we go back into the project and backgrounds and buttons right here, we have the background. So if I select the UI image and I'm going to drag and drop the background right here, and bam, here it is. This is our background. Now, of course, here I'm going to say background image. I'm going to click on native size. So set native size. This is when we select the image, and in the inspector panel, in the camera, or here in the image, we have a property and we have a button called set native size. If I click on it, bam, here it is. This is the native size of our, background. So you can see here the background now is covering the whole screen. We are also going to duplicate this background, and this is going to be the title. So here I'm going to name it title image. So title img or image. And I'm going to search here in backgrounds and images for title. Here it is. This is title. And I'm going to put it right here where the source image is. And bam, here it is. This is our image. Now, again, in regards to dragging and dropping these images, you can simply drag and drop it like I did. Or you can click on the little circle here where it says source image, and then you can search for the image right here and simply type, for example, title. Here it is, and bam, here you are. And title is spelled with 2 T. What did I do here? Let me just go here, and it's title like this. Is it spelled with 2 T? Yeah, I don't care. I'm gonna spell it like that. And in regards to the width and the height of the title image is gonna be 430. So 430 for the width, and for the height, 390. And position Y, I'm going to say at 252. This is where we want it. So this is what we currently have for that image. Now, when you select it, Here you have a rect transform and you have position X, position Y, position Z, width and the height. This is where I set the width for 30 and the height 390. Let me just fix the scale to 1. For some reason it's at 0.99, so I've just fixed it for, well, to be at 1. What we also need is a button background, which is also going to be, well, an image. So I'm going to duplicate this title image, and this is going to be BTNBG. This is how I'm going to name it, and it's this blue shield. So simply select the button BG, drag and drop the blue shield right here where it says source image, and bam, here it is. Now, the width of this is going to be at 372. The height is going to be 206. And the position Y for it is going to be at 31. Why like that? Well, now because we have a button, and in order to create a button, we simply need to right click, UI, and we have a button. And bam, here it is. This is our button. Now we are not going to use this default one. We are going to edit it. So this is going to be our play BTN. This is how I'm going to name it. If you click on the drop-down list for the button, you will see it has a text by default. You see this button that is written, that's because of the text. If I deactivate it, you see we don't have the text anymore. So I'm going to delete it. We don't need it. And select the play button and select the play texture. Drag and drop it here under source image, UI sprite, and bam, here we are. The width of this is going to be 181 and the height is going to be 75. And position X for it's going to be 0. Position Y is going to be 23. So this is our main menu. Now you saw in the preview that this circle was, well, circling around. It had an animation. This jungle was also stretching and going back, stretching and going back. So these are the animations that we are going to create, but we're going to start with that in the next video. And now that we have finished our main menu, let us animate the title and this circle, which is, well, the background for our button, just as we saw in the preview video. Before we do that, I'm going to right click here in the project tab and create a new folder where we are going to store our animations. So here I'm going to, well, name the folder animations. Inside of it, we're going to create another folder. This is going to be our title animation and another folder. So right click, create folder. This is going to be our circle. So circle animation, or however you want to name it, but this circle is the circle background for the button. This is really important. With this, I mean organization. Don't you throw things away in your project, like put the animations anywhere. I mean, you can do that, but it will get your project really messy. So it's a good idea to create folders such as these. So animations, and here we're going to store the animations. And title animation, this is where we are going to create an animation for our title. So in order to create that animation, you need to select the title image, here it is, and go in the animation tab, which is this one right here. I've talked about these tabs in the previous video. If you don't have a tab right here called animation, you can go under window and here it is, bam. Now let me demonstrate that. So if I close the tab, I don't have it anymore. I need it, so I'm gonna go under window, click animation, and bam, here it is. In most cases, it's gonna be floating like this. Sometimes it is docked like this, for example, but if it's floating and you wanna put it somewhere else, simply take it like this and drag and drop it wherever you want it. This is my setup, by the way, for Unity Editor. You don't need to do it like this. You can have your own setup, experiment with it, and then simply save it here under, well, any layout name that you want. So now that we have the title image selected, which is really important, so select the title image. That is really important. When you select it, go in the animation tab, and now you can click on create animation. So let me just select the title image again. To begin animating title image, create an animator and animation clip. So we're going to click on create, which is going to create this pop-up window or open it. And here in the title animation folder, so you see here I'm in assets, animations, title animation. This is where I'm going to save these animations. I am going to call this one title animation, and I'm going to hit enter, and bam, here we are. So now we can start animating our title image. If we go here into the project and title animation folder, you see here we have title animation. This is the animation clip itself. Title image, this is the controller. So if I select title image, you will see now the animator component is attached on it. This title image, as you can see here, is the controller. So animator controller for this animator. Now what we need to do, we need to go into the animation, select the title image again. You see this little red button right here where I'm pointing with my mouse? So here it is under the animation tab. You have these play, rewind, go to previous keyframe, go to next keyframe, and here you have this red image, enable disable keyframe recording mode. If you played with any video editing software, you know this, or this red key icon is familiar to you. So when we press on it, it will start recording everything. So what we need to do here? Well, first things first, we are gonna change the width and the height of our title. So I'm gonna go under frame 15, and by the way, you see these samples here? It's 60, that means we have 60 frames in this animation. But here, you see this tab where it says 0. Here I can type 15, which means it will take me to frame 15. You see now this line here indicating where we are in the animation, this white line, is now on frame 15. What happens on frame 15? Well, I'm gonna change the width to 230, and I'm gonna change the height to 350 for the title. Not 250, but 350. Now, after that, I'm gonna go on frame 30. So here I'm gonna, instead of 15, type 30, hit enter, which is gonna take me to frame 30. And on frame 30, I'm gonna set the width to 190, and the height is gonna be at 350. I'm not gonna touch it. Now I'm gonna go back to frame 45, or not go back, but actually go to frame 45, hit enter. Here I'm gonna set the width to be 290. The height is going to be 360. And lastly, we're going to go on frame 60. So here, instead of 45, type 60, hit enter. Here, I'm going to say the width is going to be 440 and the height is going to be 400. So now I can click again on the recording button. It will stop recording everything. And well, voila, we are good with the animation. So we can, well, preview the animation, and in order to preview it, I can go back here, click on this play button. You see, this is the jungle run animation. We can also run the game. So if we hit the play button now, this is the jungle run animation. Now, you see, I don't want it to be this fast. How can we change this? Well, in order to change that, we can go in the Animator tab. You see here, now we have the Animator tab. Again, if you don't see it, under Window, you have Animation, and you also have Animator tab. The Animator tab displays these animation clips. So you see title animation is right here. We can double click on this, and you see here it has the loop time check, which means it will loop the animation itself. If this is not checked, it would not loop that animation. Now, what we need to do here is click on the title animation, and you see here the speed of the animation is 1, which means 100, normal speed of the animation. I am gonna click 0.5, which is gonna play that animation 2 times slower than its own actual speed. So if I hit the play button now, you see the jungle run animation plays a little bit slower. So actually it plays half the speed it did before. So in order to do that, again, you need to go into the Animator tab, select the title animation. If you select something else, sometimes if you select something else, it will not display anything here, but make sure that you select the game object you want to edit, and you will see all of its animations right here. So I'm going to click on title animation, and in the inspector panel right here, you have the speed property. Setting it at 0.5 will make it go half the speed of its original speed. So half of its original speed. So again, if I hit the run button, bam, this is what we have right here. Let us now animate the circle, and in order to do that, select the button BG. Again, click here, create, and we're not gonna save that in the title animation, we're gonna save it in the circle animation right here. So I'm gonna name it circle animation like this, and hit save, and bam, here we are. Now we are gonna do a similar thing, and that is we're gonna click on the recording button, go on frame 30, and we're gonna edit here the Z rotation. So the rotation here, we're gonna set it at -360, and we're gonna go on frame 60 now. So frame 60, and we're gonna set this at -720. So if I stop recording now and hit the play button, you see our, circle is rotating. And if I hit the play button again, bam, you see the circle is rotating. Jungle Run is also stretching and going wider, stretching and going wider and whatnot. Now, in regards to the circle, you see it's rotating, then stopping, then rotating, then stopping. This is because of the animation. Now, we can fix this with some lines of code. I did it like this, but you can create a script, attach it, and animate it, or actually simply make it rotate with code. I'm not gonna show you how to do that. You can search that on the internet, but I'm just pointing out that there are multiple ways to solve a certain problem in, programming. And that's why when people ask me, why did you do it like this? Why did you do this like this? Why did you do that? That was my own preference. I thought that that was the best way to solve that in that particular moment, which does not mean it's the best code to solve something. You can always, always, always optimize your code. You can always add some new things to make things work better, so on and so forth. So if you see me do something, that is my own logic. I used animations here to, create these effects. I did not use code, even though all of this right here that you see, this stretching of the title, rotating of the circle, all of this is doable through code. But this is the more simpler way, and that's why I am showing you how to do it like that. So now let's go into our gameplay scene. So what we need to do is first click on File and then New Scene. Shortcut for that is Command N on Mac, Control+N on Windows. So if I click New Scene, it's gonna take me right here, and I'm gonna hold Command press S to save it. So Assets, Scenes, this one is gonna be named Gameplay. The first thing that I wanna do is set up our gameplay scene. Yes, again, we're gonna set up things. Still, we're not gonna code, so deal with it, I don't care. Anyways, I'm gonna right click here in the hierarchy panel, go under UI and create an image. This is gonna be our background. It comes with a canvas right away, so I'm gonna rename it to UI Canvas. Change it from Screen Space Overlay to Screen Space Camera and attach the main camera right here. Take the image and I'm gonna set it at 0, 0, 0, but before or after I do that, we are gonna set the UI scale mode to scale with screen size 480 by 800, and we are gonna match width and height equally. Now what we need to do is we need to add a background to our image, and that is gonna be under backgrounds and buttons, the sky image. So let me take it right here, rename it to background instead of image, drag and drop the sky image right here where the sprite is and click on set native size. Now you see the image is not how we wanted it to be. Because of that, I'm simply gonna set it at 480 by 800 for the width and the height, and voila, here is our image. I'm also gonna change the color. Now we have this purple white color. I don't want that. So for the color in the image property, we have the color. Hex color right here is gonna be at 76 F9, so 76 F9 FFF. This is the color that we want. So let me just go here in the game. Yeah, this is exactly the color that we want to have. Now, what we are gonna do is create another image by duplicating the background image. Just simply duplicate it. And these are gonna be our back trees like this. And for that, we need to search, for our tree 1 image. So I'm simply gonna put it right here instead of the sky. Now, this is not how we want them to be. So I'm gonna change the width to 560 and the height to 450. And the position, I'm gonna say here for the Y, -212, and voila. These are our background trees. Of course, since we have duplicated this background, we have changed the color. So I'm going to put the color back to white or the normal color. So now they are green as any normal trees, are. We are also going to take other trees, which are our front trees. So let me just take them right here and place them, something like this. Now these are going to be our front trees because they are in front of these trees. And this one, let me just name them front tree 1. I'm going to set it here. So let me say 0.5 for the X, 0.6 for the Y. That is the scale of it. And please notice, this is not a UI element. So this is a simple game object. I have simply dragged and dropped these trees right here in the scene folder, or actually in the scene view. So I did not create a UI element for them. As you can see, we have the background and we have the trees. If I turn off the canvas, we are left with the front trees. So don't be confused. They are not a UI element. They are a simple game object. Now here I'm going to set it at -3 let's say 3, and for the Y I'm going to say -3.5. So this is where I'm going to place this tree, and for our other trees I'm simply going to duplicate these, and this is going to be our front tree. Let me duplicate it again. So this is going to be our front tree 2. Now this one is going to be positioned at 3, so -3, or actually +3. And for the Y, I'm going to say 3.9. So these are the trees that are going to be in our game, which gives that depth effect for our game. Now, the next thing that we need to do is we need to add our bounds. And for that, we have the bounds right here. So they are, let me just find them right here at shield, side boundaries. Here they are. So these are the bounds that we want to add in our game. Now we're going to duplicate these, but before we do that, I'm going to change their scale to be 0.76 on the X. I'm not going to touch anything on the Y, and I'm going to set 0, 0, 0 for, the X and the Y position. So this is our level. This right here that you see is our level. What we need to do now is we need to add 2 box colliders to them. Why 2? Well, because I don't want 2. I'm not going to slice these. If I open these, as you can see, these are 2 separate boundaries. So one is here and another is here. I'm not going to use the slice machine or the slice sprite editor right here to slice it like this. So one is here and another is here. I don't want to do that. Instead, I'm going to use them as they are, but I need to add 2 box colliders on them because we want to prevent collision from our player going outside of these. So if I take the side boundaries, we are going to add 1 box collider and we are going to add another box collider. Really, really, really important thing to know. When you are working in a 2D project, so you're working with a 2D game, when you filter for a box collider, so you have a box collider here and you have a box collider 2D. Box collider is for 3D game objects, so be very, very careful about that. Box collider 2D is for 2D. So you need to be careful about it, because if you add a box collider, this one, the 3D one, your code will not work because we are working with 2D. So what we're going to do with the first box collider, well, offset is going to be at 4, actually here, offset is going to be 4.29. We're not going to touch offset Y. Size X is going to be 1.61. And the size Y is going to be 1024. And if I take all of these game objects and deactivate them, we will see what I'm talking about. So I'm going to take the other box collider, which is this one right here. And for this one, we are going to say, well, the offset is going to be at negative. So this one's going to be negative 4.29. Offset Y, we're not going to touch it. Size is going to be 1.61, so 1.61, and we're not going to touch, well, the other size for the Y. As you can see here, we have 2 box colliders. Let me just take this right here and position it here so you can see it. One box collider is here, and if I move it, let me just move one of these. Okay, I'm moving this one on the left side. You see, I'm moving it. Let me just remember or memorize the value. So I'm moving it. This is one of the box colliders. You see it? The green thing right here. This is for the left one. And this one right here, the other one, this right here is for the, well, right one. So we have two of these that are gonna represent boundaries on our two, let's say, call these pipes. I'm gonna call them pipes, and I don't care if they are not actually pipes. I'm gonna call them pipes. Don't you come with me, okay, technically they're not pipes, they are this, I don't care, okay? So we need 3 more of these. So 1, and this one is gonna be positioned at 10 for the Y. 2, this one's gonna be positioned at 20 for the Y, and 3, and this one is going to be positioned at 30 for, well, on the Y. So this is what we have. These are the boundaries, and since I am a control freak or organization freak, I'm going to right click here, create an empty game object, and I'm going to name this one player bounds like this, position this at 0, 0, 0. Now, when I say position this empty game object at 0, 0, 0, that does not mean anything. I just like them to be positioned like that. I don't want this to be at 200 here and 351. No, I want them at 0, 0, 0. Select all 4 of our bounds. So we have side boundaries 1, 2, and 3. Drag and drop them under the player bounds, which is our parent game object. And voila, this is what we have. This is our official level. And we are done with editing it. The next thing that we need to do is actually make these bounds move. You see, we need to make them move like this in order to simulate an infinite background effect. And we will start doing that from the next video. So let's get into some coding. Inside of the project tab, I'm gonna right click and create a new folder, which I'm gonna call, well, you can assume scripts. Duh. And here I'm gonna right click and create a new folder, and this is gonna be our BG scripts, because here we're gonna store the background scripts, or actually the ones that are gonna move these pipes or these obstacles or bounds or however you wanna call them. So here I'm gonna right click, create here BG mover. So BG mover like this, and we need to attach it on all of our side boundaries. So I'm gonna select all of them by, well, selecting one, holding shift, then selecting, well, all of these. And right here under add component, I am gonna filter for the BG mover and hit enter. And this is, well, the way to add this script to all 4 of our bounds. Now I'm gonna, well, double click the script and open it here in Mono Behavior, or actually Mono Develop. I'm gonna tag the class here at the bottom, hold enter just to give a little bit of space as always, which we are used for me to do. So we need a couple of variables as always when we start a script. The first one is gonna be a public float, which is gonna be the move speed. I'm gonna set it at 3 by default. Let's say 5 by default. This is the default value. I set it to be public, which means it will be visible here in the inspector panel. Bam, here it is. So we have the BG mover script. We have the move speed value right here. Default one is 5, as we just saw. We also need to get a reference to private game objects. And this is going to be an array, and these are going to be our side bounds, not sounds, but side bounds. What is this? Well, we're going to get all 4 of these boundaries from the scene because, well, we need to calculate where we need to reposition each bound. So we will see that in a second. We also need a private float. So float is going to be our camera Y. This is the Y position of the camera. We also need a private float, and this is going to be our bound height. This is the height of our bounds. And this is all what we need for now inside of the awake function. So I'm going to change start to awake, and I always get this question. Why did you change awake or start to awake? Why are you using awake and not start? You can use either awake or start, but I talk about this all the time, and all the time I get questions about this. So we have awake, we have void start like this, and we have void on enable. All three of these functions are used for initialization. Now the difference is in the order of execution. The first function that's going to be called when you start the game is awake function. The next one will be onEnable, and the third one will be start. Now, usually you are going to use awake and start, and awake is called before start. That's why I like to use awake. It's my own preference. You can use start as well, and it will work the same way. So inside of the awake, we need to get the reference to all of these bounds, but we need to get them using their tag. And in order to do that, we need to go back here in the scene editor or Unity editor. When you select any of these game objects, you will see here in the inspector panel below the name of the game object, you have these tags. It's a drop-down list. So you can click on the drop-down list and you can go here, add tag. So click on that, and then here you can create your own custom tag by clicking on this plus button right here. So if I click on the custom plus button, I can create my own tag, which I'm going to call side bounds like this, or side bound, however you want it. And I'm going to click save. So it's side bound. They are put together. This is one word, no space between side and bound. This is important because now we need to tag. So select all of these side boundaries. And from the tag now, you can select that side bound that we have created as our own custom tag. So here it is when you select it. Notice now every single one of our side boundaries will have that side bound tag. So all four of them. Now, why did I say this is important? So it's important because now we can go here in our awake and we can say side bounds is equal to game object, find game object. So here we have plural, not singular. So S, it's object with S. We can remove that and we can only find one game object with the tag. But since we need an array, meaning all game objects in the scene, which carry the tag that we specify right here. So the tag is side bound. Now, what is important here? This side bound, this tag name right here needs to be exactly as the name right here. So we see it's side bound, no space between side and bound. If we do something like this here, type space between them, we will not find those game objects and we will have a problem. So it needs to be the same. Same signature, same capitalization, everything needs to be the same. We also are going to get the camera Y. So camera Y is going to be equal to camera.main.transform, actually .game object .transform .position .y. So this is going to give us the Y position of the camera. And what we also need to calculate is the bound height, which we calculate by using the box collider. So we need to get the box collider. Now notice both box colliders have the same size on the y-axis, so it does not matter which box collider we get. So simply here we need to type get component box collider 2D, and we need to say bounds dot size dot y. This is going to give us the height. So how high, how large. When I say how high, don't think about smoking weed or something like that. It's the height. So how high is the bound game object? This is important because, well, we need to recalculate its position. Before we do that, so before we recalculate the position, we are going to move it. So we're going to say here void move. This is a function that we have just created, which we are going to call in the update right here to move our game object, so our bounds. And we're going to do it simply by using vector3 temporary variable is equal to transform.position, so the current position of the game object. Temp.y is going to be minus equal to move speed multiplied by time dot delta time. And below, we simply need to say transform position is equal to temp. What are we doing here? Because some students do not understand this. If I take my highlight tool, we have created a temporary variable. So this is a variable temp to temporarily store the value. So to store the current value of our own position. So POS. So our current position is stored in the temporary variable. So now we are using the y value of the temporary variable, subtracting from it the move speed. So move speed like this, multiplied with the time delta time. Now delta time is a very small number between each frame. So if we have 60 frames in a second, that is a very, very small number, and it's used in calculations like this. And simply then we use our current position, so POS, and we assign it the new position, which is our temp. That's the new position. So simply reassigning it back. So currently here we are storing it. So this is our current position. We have edited our current position and we reassign it back so that we have a new value of the position. So think of it like this. I have $10 and I give you that $10. So I give it to you and I tell you, okay, these are my $10. Store them for me. So temporary, hold them for me. But also go and buy me some gums, and that gum costs $1, for example. So $1 is the gum. So now from 10 you have 9. So that means you have 9 now. You bought me the gum and I tell you, okay, give me back my money. So now you give me back the current value or the edited value, which is now 9 and not 10 anymore. So it's not 10, now it's 9. So we are done with the movement. So here we have, well, calculated the new position. We are calling that in the update function. We can go back here and we can, well, simply hit that play button to see that they are actually moving down. You see, they are moving down and eventually they will run out and bam, this is the trouble that we have, or the problem, well, that we have. Now, it's not that bad idea since we have these box colliders on these game objects. We can select all of these and we can add a rigid body 2D, because if I just move it up, let me just move the component up. And why did I add a rigid body to all of these game objects? Well, the reason for it is because we have box colliders on them, and when you want to move game objects with colliders, it is a good idea to add a rigid body on them. But before I proceed, I will show you one problem that we have. So our game objects are simply going to fall down. You see, they just fell down. Now you might think this is okay because we have the script, but if I deactivate the script that is moving them, even if I remove it, they are gonna fall down. You see, they're falling down. The reason for it is because the rigid body is applying gravity to our game objects. So what we need to do is we need to go here and set them to be kinematic. So here from the drop-down list, body type is not dynamic anymore, it's kinematic. So I'm gonna put them here as kinematic, and if I hit the play button, so now they are going down, but because of the script. If I deactivate the script, so BG Mover is deactivated, they are not moving down. As you can see, they are not affected by gravity anymore. So they are not affected by gravity. If I change that to dynamic, bam, they are falling down. And this is what I mean. So let me turn back the script on again and put the body to kinematic, all 4 of these bodies. So it's a good idea when you have a collider on a game object and you're moving it that you actually put a rigid body on it. If you don't want gravity, then simply put it to be kinematic, but leave the rigid body on that game object. So what is the problem that we have now? Well, the problem is that we are moving these backgrounds and eventually they are gonna, well, go away and we are not gonna have them anymore. So bam, as you can see right here. Now also one thing that we are gonna do in regards to our side bounds is that we are gonna take these trees and let me just take them, position -2, because I want these trees to be in front of our, well, obstacles here or side bounds. You see, the trees are now in front. If I put them back at Z, so Z position is at -2. If I put it back at 0, you see in the front line, we see, I'm not sure if you're actually seeing this. I'm going to zoom it back. So here, notice all of the trees are behind these bounds. If I put the front trees at -2 for the Z, they are now in front of the boundaries because I want to create that depth effect. So now moving back to our script, what we need to do is we need to reposition them. So here I'm going to say void reposition, And we need to call this function right below the move function. So right below it here, call reposition. Inside of the reposition, we are going to test if our bounds are below the camera's Y position. So here we're going to test if the transform position, which is the current position of our bounds, dot Y is actually less than the camera Y. And for the camera Y, we also are going to do the following here. So we got the camera Y. I'm also going to subtract 15. So I'm going to say here minus 15, just so that I can give a little bit of space before we actually reposition the background. So if our current position Y is less than the camera's Y position, of course, we have subtracted 15 from it right here. So if our position is less, we need to reposition our background. How are we going to do that? Well, we need to calculate the highest Y of the backgrounds. Why the highest? Well, notice here. In the scene, you see the first bounds, this one that are here, you see I'm deactivating them. These first are at position 0 for the Y. The next one are at 10. The third one are at 20 and the fourth one are at 30. So what we need to do, when this side bound right here, so when it goes like this and goes below the camera somewhere around here, we need to reposition it back in front right here so that it can again go down like this and then be positioned back and again. So this effect is what we are gonna achieve. So let me position this at 0, 0 for X and Y to put it back where it was. And in order to do that, we're gonna say here float highest bounds Y. So this is the highest bounds Y is gonna be equal to side bounds element that's at index 0 dot transform dot position dot Y. How can I be sure that the first element in this array is the one that has the highest Y position? Well, I'm not, because when we use this game objects or game object, find game objects with the tag, it's gonna get all of these game objects that have this tag and put it in this array. Now, the order by which this function gets these game objects is always different. It does not get them like this, so side bounds will be element 0, side boundaries 1 will be element 1, side boundaries 2 will be element 2. No, it can be that side boundaries 2 is element 0 or at element 0, index 0 that is. Side boundaries 3 can be at element or index 1. Side boundaries can be at index 2. And side boundaries 1 can be at index 3. Now, my point is that it will not get them in this order so that the last or first element will always be the one with the highest Y position. Instead, we need to compare the values. So here we're going to say if, or actually we are going to say for int I, which is equal to 1. Why 1? Well, because here we used 0 index. We don't need to test element that's at index 0. Instead, we're going to test other elements. So for Y or int I that's equal to 1, I is less than side bounds dot length I plus plus. So we are going to filter through the array and we're going to test if the highest bounds Y, which we assigned to be equal to, well, this right here, if it's less than side bounds element that's at index Y dot transform dot position dot Y, that means that this element here at index I in the array has the higher value for the Y axis, which means that we're going to say our highest bounds Y is equal to this right here, like this. So what we are doing here, let me just go here and, well, demonstrate this with a highlight tool. Let's imagine that element at index 0 has a value of, let's say, 5 for Y. So his Y is equal to 5. We assign that to the highest bounds. Now, that does not guarantee that this right here, or the element that's at index 0, actually has the highest value for his Y axis. That's the reason why we are testing. So we are looping through the array here and testing if the current value of our highest bounds Y is less than Y axis or Y value from the element that's at index y. If that is true, so let's say this I currently has value 1. That's element at index 1. And that element at index 1 has a y value of 7. So the y value here is 7, which means this value here, the first one, is actually less than 7. So we are testing if it's less, and that is true. That means we need to reassign this 7 to this value because it is the higher value. So this is what we are doing here. So now that we have the highest y value for our bounds, what we need to do is simply we need to say here vector3 temporary position is equal to the transform that position, and we need to say the y value of our current bound is going to be equal to highest bounds, so highest bounds y plus the bound height, and that is that. And here we simply need to say transform dot position is equal to 10. Why the bound height? Well, if I go here, let's say the highest value is 30, and we want to reposition this one, so we want to reposition this one here. Now, if I say that the highest y value is 30, and I want to position it above the one, and if I put it here at 30, notice it's at the same spot. So it's exactly here. You see, we have this one, it's right below it. Let me just go here. Come on, reposition back. So it's at 30. So it's at the same, you see, they are at the same position here. We don't want it. We want this one to be above that one right here. And we know that all 4 of these bounds have the same height. So we can use that. So we can say, okay, I want this to be at position 30, but also I want to add to it its height, and its height is equal to 10. So that means plus 10, that means it's 40, which means bam, it will position it, you see, it will position it above the down one, so the previous one. Actually, it will reposition it back. So we have it right here. So we have calculated, we're calling this, let me just save the script. It's really important. What did I do here? Okay, so I just duplicated this code, so sorry for that. Anyways, it's really important that you save your scripts every time you type some code out. Command S or Control S on Windows to save the changes in your script. So we are calling these functions here, and let's see that magic happen. So if I go here, hit the play button in the scene, notice now when this one, you see it's repositioning it back. Did you see that? It is repositioning back these backgrounds. And notice here how we have that in our game. So this is how we have it in our game. You see that little gap that we had? Yeah, we have this gap right here. So we can fix that gap by doing something like this. So we can say bound height, let's say -1. Just to, well, subtract 1 from our bound height so that we can actually fill out that gap. So if I go back here, let's see if we have that gap again between these. No. So yeah, this is the effect that we want. We don't have the gap between our bounds that we had, well, a moment ago, just by subtracting 1 to fill out that gap. And notice, they are repositioning this whole time. It's calculating where is the highest y value all the time. And it is putting these back up and up and up and up. So we have this infinite background effect. And if you take a look at here, you have an assumption. So you have a feeling like the camera is moving, but actually no, the bounds are moving down and you think the camera is moving upwards. So this is some new features that we have learned so far, because most of the time in Infinite Runner games that I did, or tutorials that I did for Infinite Runner effect games, I moved the camera, but now I'm moving the game objects themselves. So you see what I was talking about. You see this one? It's going to be repositioned on the top. Bam! It's on the top. And again, they are stacking upon one another. So this is what we are doing here. Calculating the highest y and repositioning it back using the highest y plus the bound height -1 to fill out that gap. And now that we have our obstacles moving, let us add our player in the game. Now, before we do that, inside of this assets folder, we have the player, enemies, and obstacles, and backgrounds and buttons. We can create a new folder here. So I'm gonna name this one to sprites. and select player, enemies and obstacles, backgrounds and buttons, and put all of this inside of that sprites folder, just so that we group our sprites right here in one place. So if we go here inside of our player folder, first sprites, then player, we have these player animations here. So we have the run animation, jumping animation, and fall down, which is his dead animation. What we need to do is create a new animation for the player. Before that, in the animations folder, I'm gonna right click and create a new folder. This is gonna be player animations, and here is where we are gonna put the player animations. So sprites, player, select the run animation, this one right here, and well, drag and drop all 4 of these. So 1, 2, 3, 4, and drag and drop them right here in the scene view. And now when we do that, bam, this pop-up window pops up asking us to create an animation because we added 4 or selected 4 images. And we're gonna select animations folder, player animation, and here I'm gonna call this one run right and hit enter to save. This is gonna be our run right animation for the player. Why run right? Well, we'll see that in a second. First, I'm gonna rename this game object to player. He is too big for our game as we see right here, so we need to, well, resize him. Select the player, scale on the axis 0.2, on the Y 0.2, on the Z 0.2. Here, I'm gonna say 2 for the x-axis and -1 on the y-axis. This is where we are gonna put our player. So this right here, and let me also take the player and change his Z position. Let's say Z is gonna be at -4, just so that our player is visible on top of the obstacle. If I hit the run button now, notice what we have. Our player is running on the obstacle. Before we proceed with the animations, because we need to, well, prepare these animations for our player, we are gonna click here under Add Component, filter for Box Collider 2D, and voila, here is our player. So we have the Box Collider here, and I'm gonna resize it because as you can see, you see this right here, this is not how we want it. So I'm gonna set the size on the X at 2.98, size on the Y, let's say 5.9, and offset it on the x-axis by 1.34. So this is what we have for our Box Collider. Voila. Let me just put the player back here at 2 for the x, and we need to add a rigid body, as I already said, for our player because we will be moving him and he has a Box Collider. And filter for rigid body 2D. We need to make it to be kinematic because if we leave it like this now, bam, you see the player fell down, which is not what we want. So select the body type here, drop down list, and click on kinematic. And we are done or good to go. Going back into the assets folder in the project, right click, create a new folder for prefabs. And inside of the prefabs folder, go right here, right click, create folder, player, prefabs, not playfabs, prefabs like this, and voila, here we are. Drag and drop the player here because it's a good idea to create prefabs out of game objects that you need because a prefab is a reusable game object. If I drag and drop the player right here, here we have another player. And all of the features or all of the settings that we had for this player, now this prefab also has. And when we change something on our player, this one right here, we can hit apply at the top right corner so that that change also will apply to the prefab. Before we proceed with some scripting, we need to go here in animation, select the player himself and create a new animation. We know that when we want to create a new animation, if I select the tree, we have this create button and I click create and then we can select where we want to save that animation, blah, blah, blah. But when we select the player now, we don't have that. The reason for it is because the player has his animations, he has his controller and animator component attached on him. So in order to create a new animation, right below the red recording button, we have this drop-down list and we can click on it and we can click here, create new clip. This is gonna be our jump animation. Now, since we are on the right side right here, we are gonna jump from right to left. So here I'm gonna create a new clip and I'm gonna call this one jump left animation and save it. Assets, Animations, Player Animations, and click Save. What we need to do is put this Animator tab right here, go into the Sprites Player folder, and we have these jump cycles. So we have 4 of them. Drag and drop them and put them right here, and here they are. Let me just zoom in a little bit, zoom in a little bit more, and voila, here they are. Now, I don't want them to be right here, right next to each other, because like that, notice here, this is the animation now that we have. This is our jump left. You see the player is like crazy, and we do not want that. So we are gonna take these keyframes. So take these 3 keyframes and move them like this, and let's go on frame 15. So let me just move these keyframes a little bit more. On frame 15, this one right here, drag these 2 or the first 2 keyframes. So these 2, drag them on frame 15. We're also going to go on frame 30 and you see where this is going. So here we have frame 30, this one right here. Let me just take 2 keyframes and put this on frame 30 and frame, 45. Put these 2 keyframes. Actually, we can move these a little bit, something like this, so that I can put this on keyframe or these keyframes, something like this. So first 2 keyframes, you see, they're gonna be on frame 15. Next 2 on frame 30, then frame 45. So these 2 need to be on frame 45, and these 2 are on frame 60 because our animation looks a little bit better now. You see here, our animation looks a little bit better. Don't worry about the animation being slow. We will speed it up in the animator panel. So we will speed it up, so don't worry about that. But the important thing is that we have created that animation. Now, as you can see, our animation is not that good. You see, the player is very small. When we stop the animation, this is the player's normal size and whatnot. So in order for us to begin the scripting, we need to fix these animations because we are not going to use some code that's going to put our player from this position to this position. Instead, we're going to use all animations. So we will animate the player running on the right side, then animate the player running on the left side, and animating the player jumping from left to right and vice versa, from right to left. So what we also need to do is go in the run animation, run right. I called it run right for a reason, because we need to hit the preview, or actually the recording key. We need to hit it, change the X like this, change it to any value. So X position, change it to any value, and now put it on 2. And go on the last frame, this one right here, and again, put it onto, or actually change it just so that we record. When I say change, we need to record so that we record this keyframe. So we need to have these keyframes. As you can see now, we have our player sprite position, but put it again at 2. Why at 2? Because this is the player's running right animation, as you can see right here. So we have him running on the right side because we are also going to have him running on the left side. And in order to have him running on the left side, we need to select the player, go in the animator, select the run right and duplicate it. Not jump left, duplicate the run right animation. So here it is. And now take the run right animation, rename it from run right 0 to run left and hit enter, and bam, save this. Select the player again, go into the animation tab, and now we have, so we should actually have another animation. No, we don't. So we need to improvise and go back here, delete this one and create a new animation. I thought this is going to work. So create a new animation clip, and this is going to be our run right, because, or actually run left. So run left, and again, we need to drag and drop our animations. So go here, we have running animations, these here, and let me just go here and see where they are. Let me compare them with the running right. So yeah, they go from, 0 up to 3 frames. So this is okay. And this one right here, run left, does the same exact thing. So it does the same exact thing. But what we need to do is the following. hit the recording button. So hit the recording because now we need to, well, run on the left side, which means that our player needs to be on -2, you see right here, and also -0.2 on his scale. And we need to go here on the last frame and just change the position. Just so notice here, notice we don't have keyframes right here, but if I change the position, bam, you see we have keyframes right away. So put it at -2 and also change the scale just a little bit, just so that we get the keyframes. And we are gonna set it at 0.2. Why is that? Well, now we have the animation running the player from, well, on the right side, and also we have the player running on the left side. If I hit the play button, you see, this is what we have right here. Now, don't worry about the animation being that fast. We can always, well, turn it down a little bit. So if I go here inside of the animation, this one has 60. If I set it to 12, and if I hit the play button, so yeah, simply change the frames. You have here samples. You see, samples are set on 60, which means 60 frames in a second, and the player is running like crazy. You see, like a roadrunner. But we don't want that. Set the samples on 12 because for the run right, samples are also on 12, so the player runs like this. Let me just go back to run left. It's the same exact thing. Now, in regards to the jump left animation, what we need to do. So we need to animate our player jumping, well, from right to left. Before we actually animate our player jumping from right to left, let us select the first 3 keyframes and put them back like this. So the first one will be at 0, the second 2 will be at 15, and the second 3 or the third 2 keyframes will be at frame 30. The last keyframes can be on frame, well, 60 or the last frame right here, because this will make the animation look a little bit better. Now what we need to do is go on frame 30, and when our player jumps, we are gonna hit here the record button, set the position Y at 0, and set the position X at 0 so that our player gets here. And go on the last frame, set the Y position at -1 and the X position at -2, because now you see this is that animation of our player jumping. Now our player is very small. You see here, when he jumps, he gets very small. We don't want that. So going here on frame 0, hit the recording button, set the scale at 0.35 for the X and 0.35 for the Y. So Y and X are going to be 0.35. Do the same thing here for our, well, for the last frame. Let me just put it like this and like this. So now I'm going to set it 35, 35. So simply change the number at the last frame so that you get the keyframes and put them back. So the scale is 0.35. Scale Z is not important. Only X and Y. So notice now when we jump, this is what we have here. So player is jumping. Don't worry about the animation being a little bit slow. We will fix that later on in our code. We can go here in the animator and we have, well, jump left. Let me just see where my animations are. So we have run right or run left. Here it is. Let me just resize the window so that we can see more clearly. Run right and run left, and we have jump left, and we will have jump right. So if I take it here and put it at 2.5 speed, it will run 2.5 times faster, you see, as its original speed. But we can see that in our game. Now this right here is a setup for our player animation, because this way it is much easier. We can simply use the jump left animation. The player will jump from right to left, and then from here we can continue to play run left animation, which is this one right here. And when the player jumps from right to left, we can continue to play the run right animation, which is this one right here. This is much more easier than if we had to do all of this from our code. Now to get this, or to paint a clear picture to see how easy this is, actually we need to start coding, but we are going to do that from the next video. And Fahir here from awesometuts.com. If you missed something in regards to these animations, you can rewind the video to see how I animated everything, or Download the complete project, link is in the description below to see how I set things to be animated. And now that we have our player animations, let us program the player's movement and jumping. So if we go here in the scripts folder, right click, create a new folder, player scripts. Inside of this folder, right click and create a new C# script. Let's call it player, and attach it on the player right here. Hit apply so that this change applies to the prefab. What we need for our player? Well, we need to animate the player. We also need to be able to click on the screen and make the player jump. So before we continue to program, we need to add a UI button right here in the middle. So if we take our canvas, right click and go under UI and create a button, bam, here it is. This is our button. Now we need to resize it. So resize the button to be right here to fit the whole middle or 1/2 of the screen. So this button needs to be on 1/2 of the screen so that when we run our game, we have a button right here that we can click on. Now, this is very ugly. We don't want it to look like this. So first things first, remove the text from the button. We're also gonna rename this one to Jump BTN. So Jump BTN, this is the name of the button. And inside of the inspector panel of the button, here we have the color. We're gonna click on it, which is gonna open this pop-up window. And we are gonna set the alpha to 0, you see, which is gonna make the button transparent. It is still clickable, but it's not visible. So now we need to go here. Before we start typing anything, we need to type using Unity Engine UI because the button is under this UI. If we don't type it out, we will not be able to get the button, and we need to get it in order for us to program it for it to do something. So what we need is a private animator, which I'm going to call anim. We also need a private boolean on left, on right, and a private boolean, so private bool jumped like this. Inside of the awake function, we are gonna, initialize these variables. So in the awake here, we are gonna say anim is equal to get component to get the animator component that is attached on the player. And we also need to get a reference to our button. But before that, I'm gonna say here on right is equal to true, on left is equal to false. This is to initialize on left and on right. These on left and on right are gonna determine the side on which we are. So it's gonna determine if we are currently on the right side or on the left side. And this is for the jump animation. So we will deal with this in a moment. Don't worry about that. What we need to do is create here a function. So public void jump. And this is the function that's gonna allow us to jump. And we need to add it to the button by typing here game object. Find the game object with the name jump BTN like this. So if I go here in our Unity editor, we see that we named our jump button jump BTN. So that's the same thing we need to type right here. Now pay close attention. This name right here that you put, so jump BTN, this one right here needs to match up with this right here. If you make a mistake, this will not work. But we need the button and we are gonna get it as a component. So get component button like this, dot on click, dot add listener, and this listener takes a function name. So the function name is jump, which means that now we added jump to the button, which is the function, and it will be executed when we click on the button. Just so that I can, confirm my claims, I'm gonna say here printed, something like this. It's not important, but important is that we see that when we click on the button, this jump function right here will be called. In the console, we're gonna see all of that. Let me just go here and clear it. If I hit the play button, if I click somewhere here, bam, 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 bam. You see here, printed, it's being printed in the console, which means that actually this worked. So now, our public void jump is the function that's gonna be executed when we, hit the button. So what we're gonna do in this jump function? Well, first, we are gonna say here if on right. So if we are on the right side when we press the jump button, we're gonna call our anim to play the jump left animation like this. Else, if we are not on the right side, which means we are on the left side, we're gonna call our anim to play jump right. And below here, we're gonna inform that we have jumped. So jumped is now equal to true. Why we are doing all of that? Well, the reason for it is because in the update function right here, we're gonna test if we did not jump. So if we currently did not jump, that means we are moving either on the left side or on the right side. So we're gonna test, are we moving on the right? So if on right, meaning we are moving on the right side, we're gonna call our anim to play run right animation. Else, our anim is gonna play the run left animation like this. So it's simple as that, but we are still not done because we need to go here in our Unity, select the player here. So select the player and go here. We have jump left. We need to duplicate it. And now we need to rename it to jump right. So now we need to rename it, as I said, to jump right. But what we also need to do is we need to set here the speed to be negative. Why negative? Well, because when we use jump left, it will jump from the right to the left side. But now we have duplicated that same animation, which means that if we call jump right, it will again make the player jump from the right to the left. But we need him to, well, jump from left to right. That's why we are going to use the negative. And we will see this in a second. Now, before we continue or actually do anything, we need to add one more feature to our animation. So in the animation panel right here, we have our player. And here we have his jump left and jump right animation. Let me just go here inside of our assets, then inside of our animations right here, player animations. Here it is. We have jump left, and run right. I need to duplicate this jump left and call it jump right, because we need to be able to see this animation right here. So we need to be able to see this animation right here. We currently don't see it because we have here jump left, which uses jump left motion, which is the animation. So it's the animation itself. Jump right uses that same motion. We need to select jump right and select here jump right. You see this one right here, the one that we have just duplicated. It's the same animation, but we will play it backwards. Now, as I said, the reason why we need to do this is because we need to be able to see this animation. You see, we need to be able to see it right here because we have the player jump left, which is this one right here. And let me just go here. We have jump right. Actually, yeah, here it is, sprite. Let me just take a look at it. So this is jump right. Actually, it needs to be duplicated. Yeah, it will be when we, well, go in the code. So don't worry about that. What we need to do here is take the jump left and go here on the last frame. Click on this keyframe. You see this right here? This is, well, a motion or an event, function event that we are adding at the last frame. And that is going to be a function that we need to, well, create inside of our script. So right here below our public void jump, we are going to have void on left and we're going to have void on right. So on left and on right. In on left, we're going to say on left is equal to true, on right is equal to false, and jumped is equal to true, or actually false again. Copy all of this here. In on right, we're going to do, well, the opposite. On left is false, on right is true, and jumped will be equal to false. So if we go back in Unity and here select that event so that you can see it like this as I see it in the inspector panel. So now you have a function to select. So I'm going to select here. This is jump left animation. So we have the jump left. Here we are going to call on left. As you can see here, we need to call on left. And for the right animation, so for the right one, we need to call on right. So if I go here, we have run, actually this is not run, jump right, here it is, jump right, we need to add that event here at the beginning. Why at the beginning? Well, because we're gonna play this animation in backwards. We will see this in a second. So if I hit here, add the keyframe, click on it, so you need to click the keyframe and select the function on right. So now we are good to go to test all of this out, and then I will explain it again line by line and what is going on. So if I hit the play button, you see here, I hit the play button. If I click here to jump, we will go to this animation as we just saw. Go here. As you can see now, we have a problem. That problem is the following, because this jump right needs to, well, have this loop time unchecked. Actually, this one right here too. So let me just run right, run left. Let me just see what is the problem here. So we have on right, on left is false, on right is true, and jumped will be equal to false. This is what we did, and I think this is okay. So let me just go back here in the animation, jump right. Here is our animation on right. It's calling on right. This should work. So let me just go here, hit the play button. Okay. Yeah, now it's working. I don't know why it did not work a moment ago, but the important thing is, well, let me just take the jump left. Did I turn off loop time? So turn off the loop time from jump left and also turn off loop time from jump right. And let me just test it out again. Yeah. The problem was the loop time. Now, what is loop time and how do you actually deactivate it? Well, double click on the animation. You will have these options here to deactivate the loop time. Loop time, it will make the animation loop over and over and over again. So we do not want that. Let me now explain what is going on. When we hit the play button, you see our game is running, the player is running on the right side, which means that our run right animation is being played. When we run the game, the awake function will be called. Now here we are getting the jump button, adding the listener, which means the function that will be executed when we press the button, and we are getting the component animator. But we are also setting on the right side to be true, on left is false, because initially when we run the game, our player is on the right side. In the update function, if we did not jump, the default value of a Boolean is false. If we don't type here, like this, if we don't type is equal to true, the default value will be false. So if we did not jump before, this is false. That means we are running. So if we are on the right side, we will play the run right animation. If we are on the left side, we will play run left. When we jump, if we are on the right side, we will jump to the left side. Otherwise, if we are not on the right, meaning we are on the left, we'll jump to the right side. So what is going to actually, jump to the right. Sometimes I get confused, right, left, up and down, so on and so forth. We also created events, so animation events here. Inside of the animation itself, you see here, we have created these, which means these events will be called when the animation hits that frame. You see, when the animation hits that frame, it will call that, well, event, which is actually this function. So when we get to the last frame, in this case, we are playing the animation backwards. And when I say backwards, if I set this to be negative, or actually 2.5, notice what's going to happen. So we are going to jump here. You see what is happening? You see which problem do we have here? Because we are not playing the animation backwards. We are not playing the animation backwards, this jump right, and in order to play it backwards, we simply need to set the negative to the speed. Because we are using the jump left animation. You see, the motion is from the jump left. We just duplicated, renamed it to jump right, which means that is the same animation. If you want to play it backwards, set the speed to negative. It will start playing it from the back. So it will not start from the front or the beginning of the animation. It will start from the back, which means from here. It will start from here and go to here, which means that the first frame will actually be the last frame because we are playing from backwards. When I say from backwards, if we have here 60 frames, that means backwards we will play from frame 60 to frame 0. So frame 0 is the last frame, and here is where we are putting the on right, this one right here, function to be called, which means we are not on the left side anymore. We are on the right side and we did not jump. So when the animation ends, it calls this event and these get executed. Jump is false, and when the jump is false, notice the exclamation mark will make what's after it the opposite. So jumped here is false, but the exclamation mark here is making it true because it's making the opposite. What's opposite of false? It's true. So if we did not jump and we are on the right side, play the run right animation. If we did not jump and we are not on the right side, meaning we're on the left side, play the run left animation. When we jump, if we are on the right side, that means jump to the left side. When we jump and we are not on the right side, that means we are on the left side, then play jump right. So jump to the right side. And as you can see here, jumped is true because while we are in the air, we don't want to play run right or run left animation. As you can see with a couple of lines of code, these are not that many lines of code, these are 20 or so lines of code, we managed to make our player jump from the left to the right. But if we did all of this in our code, we will need to calculate where the player is when he lands, how we are gonna animate him. So it's gonna, or that would be complicated, but like this, it's very, very simple. You see the players jumping from left to right and right to left with just a couple of lines of code, as you see right here. So it's really easy to do this with animations and we don't have to do anything complicated. Now we can also use space. Let me just take this right here. So all of this right here, and inside of our update, right below where we are testing if we did not jump, we can test if, so if input get key down, key code space, so space, if we press the space key on our keyboard, we're gonna do the same thing right here. So that same thing is actually jump, and we can test it out. So if I go back here, hit the play button, I'm hitting space now and I'm jumping. You see, hitting space and jumping, hitting space and jumping, hitting space and jumping, and you get my point. And you can watch these animations being played right here. Notice when we run the game, you see run right is being played. When I jump, you see jump from the left or jump from the right to the left animation played, and it is indicated with this bar right here. You see the blue thing that is filling, this is the bar indicating which animation is being played. So now we are on the left side because we have triggered on left. On left is true, on right is false, and when on right is false, as you can see here, we're gonna play run left. Which animation is playing? Run left. When we jump, you see we jumped from left to right, and the jump right animation was being played because when we jump, we are testing if we are not on the right side, that means we are on the left, jump to the right side. Let us add our first obstacle in the game. So we need to go into sprites and then enemies and obstacles. The first one is going to be our flag. So simply drag and drop the flag right here. And for this flag, what we need to do is set the scale on the x-axis at 1.23. Now this flag is not going to be on its own. We're also going to have the squirrel or the squirrel, and we're going to add it as a child of the flag. So before we create the animation of the squirrel, as you can see, we have 4 animations, or 1, 2, 3, 4. Yes, 4 animations from the squirrel. We are going to take the flag and we're going to add a box collider 2D on it. Now, you can see that the box collider is all around this flag. We don't want it to be like this. Instead, we are gonna resize that box collider. So the size on the x-axis can be 1024. The size on the y is gonna be 0.52. And I'm gonna set the offset y to be at 0.06. So this is this green thing. Do you see this green rectangle thing? This is our collider that is on the flag itself. So now we can select our squirrel and we can create it. Now, before we actually create the squirrel, we will create a folder inside of the animation. So assets, animations, right click, create a new folder. This is going to be our squirrel animation. So it's SQIRREL, squirrel. and we are gonna create the animation for our squirrel. So sprites, enemies, select all 4 of these, drag and drop the squirrel here, bam, here it is. And I'm gonna save it into animations, and then squirrel, and here it is, squirrel, like this, animation, and hit enter. As you can see, the squirrel is too big. If I put it right here and go into the game tab, it is bigger than the player itself, so we do not want that. What we want to do is we want to resize the squirrel, so we are going to say 0.4 on the X and 0.4 on the Y for X and Y scale. We're also gonna add a box collider 2D on the squirrel and resize it because currently it is all over the squirrel. So the size on the X is gonna be 1.39 and the size on the Y is gonna be 0.88, and we're also gonna offset it. So offset on X is gonna be negative 0.28 and offset on the Y is gonna be 0.17. Now, we also need to add a rigid body on the squirrel. So here I'm going to go add component, a rigid body 2D on the squirrel. I'm going to attach it. I'm not going to set it to be kinematic. I'm going to leave it a dynamic. And also what we want to do is we want to add that squirrel to be the child of our flag, because the flag and the squirrel go, well, one with another. Let me just rename the squirrel here in the hierarchy as squirrel, and I'm gonna, well, put it to be under the flag. Let me just set it at 0 for the x-axis, and for the y-axis I'm gonna reposition it something like this, but since gravity is being applied on the squirrel, it will be, well, it will fall down on the flag itself. Now, in regards to the flag, when we set it to be at position 0 for the x-axis, this is how it looks like. We are also going to take the flag, set it at -3 for the Z. Does this work? Actually, it needs to be at 3, not -3. So set it to be at 3 so that it is like this. You see, it's behind our obstacles. Now, one thing that we want to do is, you see, when we run the game, notice what's happening here. So you see, we have the flag and it's going or not going down. We will cover that in a moment. But we also want the squirrel to move left and right. And in order for the squirrel to move left and right, we need to create, well, a script for our squirrel. So if we go inside of our assets, scripts, right click, create, new folder, enemy scripts. This is where we are going to put our enemy scripts, well, the folder. And here I'm going to right click and create a new folder. And I'm going to say here squirrel. So S-Q-I-R-R-E-L or E-L. Yeah, that it is. Sometimes I don't know how to spell, so forgive me. Right click, create a C# script, squirrel, and attach it on the squirrel itself. So something like this, attach it on the squirrel, double click it and open it in Mono Develop. Let me just hold enter, actually first tag the class, hold enter just to give a little bit of space. And if we go here on top, we are gonna add some variables. The first one is gonna be a private float, move speed, which by default is gonna be equal to 3. And we need update. We don't need the start function, so we're not going to initialize anything, but we need to create a function that's actually going to move the squirrel. So here we're going to say void move, and we're going to use the same technique as we did with our backgrounds. So what we want to do here is create a vector3 temporary position, which is equal to transform position, and here we're going to say temp.x plus equals speed multiplied with time.delta time, and simply take the transform position is now equal to temp. If we put this function right here in the update, it will start moving the squirrel, but we will have one problem. So if we go back here and run it, you see the problem, the squirrel is trying to go away here and trying to touch things and whatnot, but it is not working. So that's not working. And why isn't working? Well, because we're just moving the squirrel to the right side. Plus equals to is the same thing as if we say temp.x is equal to temp.x plus move speed multiplied time dot, so it's time dot delta time. So let me just type it out correctly here, time dot delta time, finally, thank you very much. So this right here is the same thing as writing this here, but this is a shortcut. Plus equals to, we don't need to type, well, like this, as you just see here. Now, what we need to do, we need to detect when we touch our bounds. And since both of our bounds, so if we go here and if I select the side boundaries, you see the box collider actually, the box collider that is attached on them is not set to be a trigger. And if we select the squirrel, the box collider attached on the squirrel is not set to be a trigger. So we cannot use on trigger enter. Instead, we need to use here void on collision enter 2D, which takes a collision 2D as an argument, and I'm going to call it target. So this on collision enter will be called when two colliders touch each other. So when the squirrel touches this side of the bound, on collision enter will be called. Or if it touches the left side, on collision enter will be called. What we want to test here is if the squirrel has touched the side bound. So we are going to say here if target, so target, which is this parameter right here. So this is the target parameter collision 2D that's passed inside of this function, which enables us to get information about collision such as the game object we have collided with. So if the target dot game object and its tag is equal to side bounds. So if it's equal to side bounds, we have touched our bounds. Now we need to go in our Unity editor, go inside of our tags. So go on top. Here it is. We have side bound. So here, if we select all of these, they are tagged as side bound. So not side bounds, but it's side bound. So don't add S or otherwise it will not work. I was just going over to my Unity editor to make sure which tag we have applied. And if I left it at bounds with S, plural, not singular, then bam, we have a problem. So this name right here, in the tag, this name right here needs to match up with the name right here, or otherwise it will not work. So if we have collided with our side bounds, what we want to do, well, simply we want to change direction. So we are going to say here, move speed will be multiplied by -1. So multiplied equal to by -1, which will change the value of the speed. What does that mean? Well, that means that if the speed was positive, now it will be negative. If the speed was negative, now it will be positive. So every time we touch one side, it will make the speed either positive or negative, and it will make our squirrel go into the left or the right side. Let me demonstrate that, and we will have one problem that we will see and fix. So notice now the squirrel is going backwards. You see? The squirrel is going left and right, going left and right. Let me just zoom in. How can I do this? Okay. Never mind, you can see what I mean. So you see the squirrel is going left and right, left and right. You see left, right, left, right. Now, the problem here is that the squirrel is not changing the direction where it is facing. So what we need to do here is create a vector3 temporary variable, which is equal to transform.aLocalScale and temporary variable x, which is, well, the scale or the direction on the x-axis. We're going to multiply that. So multiplied equals to by -1. And the reason for it is the same thing. We are going to change the direction. If the scale is now positive, it will be negative. So notice what I mean. So if I go here in the scene and zoom in, you see when the squirrel hits this side, it's going to so when it hits the right side, it's going to start to go to the left side. And it needs to face the left side. So that means that the squirrel, and let me just type here 0.4, that means that the squirrel will now be facing the left side, which is the negative. You see it like this, the negative. This is the positive, negative, positive, negative. It will simply change the direction where it is facing by multiplying this with -1. So now transform local scale is equal to temp. And we can now go back in our Unity editor and test to see if the squirrel will change direction. So bam, it is changing the direction. Bam, changing direction. Bam, it is in fact now changing the direction when it hits the bounds. Now, one more thing that we need to do is for the flag itself. So here in the enemy scripts, I'm going to create a new C# script, which I'm going to call enemy move. And this one, we're going to attach it on the flag itself. So you see the flag itself. It needs to move down same way as our bounds are moving down. So if we go here in the enemy move function, or actually script, excuse me. So here I'm going to tag it with the class tag, hold enter to give a little bit of space. Here on top, we need to have a public float move speed, which is going to be equal to 1f. We also need a private float, which is going to be camera y, and inside of our start function, we're going to say camera y is equal to camera, so camera.main dot transform.position.y, and let's say minus 10f, just so that we, know from where we need to turn off our game object. Now, notice this, or what we need to do now is that we need to type void move, which is a function that's going to move our game object, and we're going to call move in the update. And we're going to do the same thing as we did with our BG mover. So vector3 temp is transform position. Our temp.y is minus equals to move speed multiplied with time dot delta time, and transform position is now equal to temp, reassigning it back. So this is nothing new. It will simply move the game object down. We did this already, but in our void deactivate, so deactivate, we are simply going to test if transform.position.y is less than camera's y. Then what we want to do is we want to say game object set active false to deactivate the game object from our game. We're going to call it right below the update. So we are going to test if our own Y position, so the Y position of the enemy move, which is attached on the flag itself, if it's less than the camera's Y that we have calculated here, then we will deactivate our game object. Deactivating the game object releases memory in our game because we are getting rid of game objects that we don't need. We don't need them in terms of when this flag goes down. So if the flag goes down like this, we don't need it anymore because it's out of sight. We don't need it. The player does not see it. It's not important to us. And because of that, we need to get rid of it. The simplest way is to use set active false, which means the game object will be deactivated. That means, notice if I select the flag, and notice here in the inspector, we have this cube icon. Right next to it, we have a checkbox, and then we have the name of the game object. If I uncheck this checkbox, bam, you see the game object is no more. It's not visible in the scene view, and it's not visible in the game view, which means it is deactivated. It is still in the hierarchy here. We could potentially activate it again if we have a reference to it, but when it's not active, all scripts that are attached on this game object will not work. All scripts that are collisions and physics that is applied to this game object will not be calculated when the game object is not active. Now we do need to set the move speed to 5 because it needs to be the same speed as our side boundary so that they move in the same harmony, so to say. So if I hit the play button now, notice it is moving down. You see, bam, it is moving down, and we, touched our squirrel with the player. Let me just take the player here, and actually the player can be set to be a trigger, and I'm gonna hit apply, because anyways, we set him to be kinematic, so he can set to be a trigger so that we don't roll over game objects as we just did with our squirrel. So if I hit the play button again, notice, bam, the game object is going down, and notice now when it goes, actually it got deactivated. So let me try this again in the scene. Notice when it goes down here, bam, it is deactivated, and we don't need it in the game anymore. So this was our first obstacle. We will have more obstacles, but before we proceed to create more obstacles, we are gonna create functionality in our side script or BG mover script to spawn these obstacles on random. So we will see that starting from the next video, but before we finish this one, here in the prefabs folder, create a new folder for enemy prefabs like this, and drag and drop the flag right here. Now the flag has this squirrel as a child game object, so it will be dragged along with it. but create a free prefab out of it because we're going to use the prefab to spawn that game object in our scene. So now what we want to do is create the functionality inside of our BG mover script, so this one right here, so that it spawns obstacles when it repositions the bounds. But before that, what I'm gonna do is select the side boundaries and create an empty game object, which is gonna be the child of side boundaries, and I am simply gonna set its position at 3.5, and this is gonna be the right spawner. So this is going to be the right spawner, or this is where we are going to spawn our obstacles on the right side. I'm just quickly going to tag it here with this tag. So it is available right here when you click on this icon. So let me just select none, and you see this cube icon right here. You can click on it and select one of these icons. So I'm going to tag it like this, duplicate it, and this is going to be the left spawner. So this one, instead of right, it's going to be left. And I'm going to set it at x negative 3.5 and tag it with the orange one. I'm also going to select both of these and set their z-axis at -2. So now I'm going to duplicate them and simply put them right here to be below our side boundaries 1. Now their x-axis is going to be the same, y-axis will be set to 0. So select both of these, set the y-axis to 0 so that it moves them right here above or where our next boundaries are. So I'm going to duplicate these now and put them below side boundaries 2. And I am going to rename them to right and left spawner. And I am going to select them, set the y-axis at 0 so that they go right here. And again, duplicate these two and put them right below side boundaries 3. Let me just rename them side spawner like this, below this one side spawner, and I am gonna put them at y to be equal to 0. X is gonna be the same, so for the right spawner it will be 3.5, for the left spawner negative 3.5, and their y-axis will be the same, which will make them at the exact same position under every parent game object. So now we can go inside of our script, which is BG mover, and right here on the top, we can create a public game object array of enemies and a public game object array of spawn positions. This is where we are going to drag and drop our enemies and where we are going to drag and drop our, spawn positions. So before we continue, we need to do just that. Select side boundaries, and here for spawn positions, set the size to 2, drag and drop the left and the right spawner. Now in element 0, first we are gonna put the right spawner. So element 0 will be right spawner, then the left spawner. Now for side boundaries 1, 2, and 3, we're also gonna set the side or spawn position size 2. Now don't put these. So you see this right spawner here. Don't put it to be right here for the side boundaries 1. So don't put them right there. You need to put their appropriate children. So right spawner that is under side boundaries 1 will go here, and left spawner will be here. And for the side boundaries 2, its right spawner will be here. Pay attention which ones I'm dragging so that you don't make a mistake. And this one I'm gonna put right here, side boundaries, and here I'm gonna put the right spawner, and here I'm gonna put his left spawner. So they're appropriate children. This is really important. Don't mix it up. Don't put this right spawner to be right here for the side boundaries 3. Put the appropriate spawners for the appropriate parents. Now I'm also gonna select side boundaries, all 4 of them, so 1, 2, and 3, and side boundaries. And here for the enemies, we're going to set the size to 1 because currently we only have the flag enemy. So I'm going to click on this little circle here and, select the flag enemy, which is our current obstacle that we have, or the only obstacle that we currently have. So what are we going to do now? Well, we're going to go here inside of the BG mover, and right here below our reposition script, we are going to say void spawn enemies. Now the spawn enemies will be called right here. So right below when we reposition, our obstacles are actually the boundaries. When we reposition them up, we will spawn enemies. And we're going to call here spawn enemies like this. Now we're going to use a random value to determine if we are going to spawn these enemies. So we're going to say if random.range from 0 up to 10 if it's greater than 0. Now, first of all, this right here is going to be frequency of spawning enemies. And it's not spelled like this, so it's frequency of spawning enemies. Now, notice here, I set if it's greater than 0. Every time this will be greater than 0. Well, that is 1 by 10 chance that it will not be greater than 0. So it means that every time we will spawn enemies. But if you want to, well, set less chance for enemies to be spawned right away, you can say 5. So that's 50-50 chance for enemies to be spawned. 3, that is 70 by 30 chance for the enemies to be spawned. 7, that is 30 by 70 chance that the enemies will be spawned. But for testing purposes, I'm going to say here 0 because we need to test right away if this is actually working. So what we're going to do here, well, first we're going to say int random enemy is going to be equal to a random dot range from 0 up to enemies dot length. This will give us a random index from 0 up to our array's length because we're going to use our enemies array, this one right here, to spawn our enemies. And on random, we will spawn, well, these enemies. Now, since our flag enemy, so the flag one with the scroll that we created in the previous video, is the only obstacle that needs to be spawned in the middle, and we set that obstacle to be at element, well, 0, so it's at index 0. For all 4 of our boundaries, the flag is at element 0, which means that here we can test if our random enemy, which is the index, and here we can say random enemy index just so that we don't get confused. So if our random enemy index is equal to 0, then we know that this is the flag enemy. And the flag enemy, here I'm going to say dash, needs to be spawned in the middle. So what you're going to do here is you're simply going to call instantiate, and we're going to instantiate the enemies, the enemy that's at the random enemy index, and we are going to instantiate it by using new vector 3. So new vector 3 like this. 0 for the x because it needs to be spawned in the middle. Transform.position.y for the y, and 3f for the z-axis. And for our rotation, we're going to say quaternion identity like this. Let me just hit enter so that it goes right here on this line. Else here, if it's not, so if the random index is not equal to 0, that means that it's not our flag. So others or other game objects will be spawned on the left spawner and the right spawner, but we will code that later on. Now we are going to test our flag if it's actually working. So if we go back here, hit the play button, and if I go here on the scene, you see when we respawn our obstacle, you see bam here we have, and bam and bam and bam. Every time we will have these obstacles, which are the flags that are being spawned right here. And when they go down, you see when they go down here, they will be deactivated. So every time they go down, they will be deactivated. And as you see, since I said here, if this random range is greater than 0, every time we see that enemy is being spawned, and the reason for it, because from 0 up to 10, that is 1 by 9 chance that we will get something greater than 0. But if you want to spawn enemies less frequently, you can say, for example, 4, that is 60 by 40 chance that the enemies will be spawned. 5, that is 50-50 chance, so on and so forth. You get my point. And here, as I already explained, because our flag is set on index 0, and we want the flag to be spawned in the middle, that's the only obstacle that will be spawned in the middle. And because of that, as I already said, we are doing it like this. So in the else statement right here, we will spawn all our other obstacles, and we will either spawn them here on the right spawner side or on the left spawner side. But before we can actually do that, we need to create these obstacles and program those obstacles. For that, we need to go into sprites and then enemies and obstacles. The first one will be our tree that we're gonna add, but it's too big. As you can see here, it's a treezilla, so it can kill our ninja just by adding it to the scene. So what we need to do is we need to change its scale. So for the scale X, I'm gonna say 0.4, 0.4 for the Y. So this is, well, how we are gonna use it. I'm satisfied with this height or how large our tree is. We're gonna attach a box collider 2D on it. Now we are not gonna leave it like this, as you see. We are gonna rescale it. So the size on the X is gonna be 4.43 and the size on the Y is gonna be 3.44. Of course, we are gonna, well, offset it. So the offset X is gonna be 0.51 and the offset Y is gonna be negative 1.3. Or actually we can leave it at -1. So -1 can be the offset for our tree. We are gonna create a tag for the tree. So we're gonna click on add tag. Click on the plus button here and we're gonna say here enemy tree and hit enter. Select the tree here in the hierarchy and we are gonna say here or select the enemy tree tag. So this is our enemy tree. We are also gonna have our enemy ninja, which is this dude right here who is also a ninjazilla. So yeah, we're gonna resize him, of course. So for the ninja enemy, we're gonna say 0.25 for the X, 0.25 for the Y. And we are gonna add a box collider 2D component on him. Of course, we are gonna resize it, not leave it like this. So the size on the X is right here, and we're gonna say 1.99, or actually we're gonna say 0.2. Actually 2, not 0.2. So 2 for the size on the X. Size on the Y is gonna be, let's say 5.38. And offset X is gonna be 1.81, offset Y is gonna be 0.62, and voila, here is our enemy ninja. And we are gonna set him to be a trigger, so we're gonna make him to be a trigger, and we're also gonna tag him. So here we're gonna add a tag, which I'm simply gonna call enemy, and I'm gonna click save. Select the ninja enemy and I am gonna, well, tag him with the enemy tag. The last enemy that we have is our bee, but our bee, as you can see here, well, we have how many? 8 of these bees. So how can we add them? Because if we drag and drop the bee like this is not what we want to have in our game. So select the bee right here in sprites, enemies, and obstacles. And you see here in the inspector panel, we have the sprite mode. This is a drop-down list. So we have single, multiple, and polygon. Currently, it is set to single, which means Unity is treating this image or this asset as a single image, but we need to have these bees separated. In order to have them separated, we are going to select multiple instead of single. Let me hit apply here at the bottom so that this change applies to this image. And now we're going to click on sprite editor, which is going to open this thing that you see right here. This is the sprite editor where we can slice each individual bee by itself, because this or these bees are a sequence of animations. Unity can slice this, well, on its own, but you can drag or you can simply draw. You see here, I just drew this rectangle with, well, left clicking and drawing it, and voila, there it is. In order to delete it, hold command, press D on Windows, control and delete. Actually, I said D, but it's backwards, or that delete. So control delete on Mac, command and the button above enter. But Unity can slice this pretty good on its own by simply clicking here, slice. You see we have the sprite editor, and if you click on the slice here, it's going to say automatic. So we want to allow Unity to slice or detect automatically where it needs to slice things. Pivot will be the center, and I'm going to click slice, and bam, here it is. So you see, Unity can slice this pretty good on its own, but sometimes it needs a little bit of help. So as you can see here, we can resize these because we're not going to leave it like this here. We're going to resize it a little bit, something like this. And select this one. Also resize it right here and on, well, down. Let me just select this one. This one is okay. The third one, let me see where it is. Just a little bit here. you can simply, well, redrag these, as you can see, to resize them, just so that it fits the B and it does not go outside of the B. So something like this will do. Select this one. Okay, we need to move this back. Now, as I said, Unity is pretty good at slicing things, but sometimes it needs help from us, as you can see right here. And this one also is the last one, like this, and we are good to go. And I'm gonna hit apply. So when everything here is done, you see, you can hit apply, which is right here, and these changes will be applied to this image. So now, when we click on the drop-down list of this image, we can select these Bs. Now, by accident, Unity has added somewhere another slice, which is, well, this empty image. So ignore the first part. I'm not gonna go back, so you will need to go back here and search where that slice is. Well, actually, it's here. Well, we found it right away. So select it and delete it. If you don't find it, it's, well, not a problem. And I can hit apply now, and bam, here we are. As I said, this is not a problem even if it's there. Just ignore it. Don't take the first image, but select all other images, as you can see here. B from 1 up to 9. Drag and drop the B right here in our, well, scene view, and go into animations to save that animation. New folder. B animation. I'm gonna hit enter, and here I am gonna say B animation. It's not like you need to be the animation, but this is the B animation. So B, let me just rename it here to B in our hierarchy panel, and I am gonna rescale it. So the scale is gonna be 0.4, 0.4 for X and the Y. We are gonna add a component on it, so it's gonna be a box collider 2D, and of course we are not gonna resize it this time. I said of course, but actually, yeah, we're not gonna resize it this time. I'm pretty satisfied with the result right here. Maybe we can resize it a little bit to be smaller, but we can test that later on to see if there is a need to do so. And here we're also gonna attach a rigid body 2D, and we are gonna make him kinematic. So here we're gonna say kinematic. And we're gonna tag the B as the enemy. So tag the B as the enemy, and voila, we are done. We need to go here into the prefabs, enemy prefabs. So drag and drop the tree, drag and drop the enemy, drag and drop the B, and select our spawners or side boundary. So select all 4 of these. And now for the enemy size, we are gonna set, well, we have 4 enemies, so we're gonna set size to 4. So now I'm gonna drag and drop the B, drag and drop the ninja enemy, and drag and drop the tree. We don't have to do anything else except attach a script to move our enemies, but we will see that in a second. We can now safely delete them here from the scene. If I hit the play button now, as you can see here, if I hit the play button, actually, yeah, why I was tripping that we actually coded. We need to code the spawning of our other enemies. So yeah, I was tripping that we have already coded that. So sorry for that. We have attached our enemies. Now else, if our random enemy index is not equal to 1, if it's equal to 1, we will spawn the flag in the middle. Else, if it's not equal to 1, or 0, excuse me, we are going to create a new game object, which I'm going to call enemy obj, which is going to be equal to instantiate enemies. Inside of it, we are going to say random enemy index, like this. We are also going to say here vector3, which is going to be our enemy scale, which is going to be equal to enemy obj dot a local scale. So actually enemy obj dot transform dot local scale. And now we are gonna determine, are we gonna spawn that enemy on the left or on the right? So we're gonna see here if our random dot range from 0 to 2, if it's greater than 0. So it's a 50-50 chance to spawn this game object or position it either on the left or on the right. So here we're gonna spawn it right. So we're gonna say here enemy obj dot transform dot position is gonna be equal to spawn positions and the position that's at the 0 index. So here we're gonna say transform position, because the position that is at the 0th index, we set it to be the right spawner. If you remember, so this you need to double check to make sure, but the right spawner should be at element 0. So right spawner, and also here right spawner, and also here right spawner. So the right spawner is on index 0. So here we are using index 0. We are also gonna take the enemy obj, so enemy obj dot scale, or actually here enemy scale dot x is gonna be equal to negative of math absolute value of enemy, so enemy scale dot x. Why is it like this? Well, we need to make sure that our enemies are also facing the correct side. We don't want our enemy to be, for example, here. So we don't want our enemy, if I take the player and pretend that he is the enemy, I don't want the enemy to be here like this. Instead, I want him to be here like this. So I want him to face the correct side. And in order to do that, we need to change the scale. And we already explained that we are changing the scale to make the game object face the correct side. Else, if the random range is not greater than 0, this one right here, we are going to spawn it to the left. So spawn left. So here we're going to say enemy obj, but let me just copy and paste this right here. So enemy obj transform position is going to be equal to spawn positions and the index that's at, or element that's at index 1, which is the left spawner. And here we are not going to use the negative, but we are going to use the positive of the scale x to make the game object face the correct side. And the last thing that we need to do is take the enemy obj dot transform dot a local scale to be equal to enemy scale, because, well, this is gonna face the enemy in the correct direction. Let me go back here in Unity, and what we need to do here, let me just clear the console. We are gonna test it out now. So if I hit the play button, we are gonna see our enemies being spawned, but we're also gonna see one problem. You see the bee, it is spawned, the ninja is also spawned, but what is happening? Well, they're not moving down. So we need to go here, select the bee, ninja enemy, and the tree, and attach enemy move script, set the move speed to 5, and if I hit the play button now, we will see that they are being spawned and going down. You see we have our flag now. Over there is the tree. So if I go back here, bam, here is the tree. We just passed it. Here is the bee. Here is the tree again. Let's hope to see the ninja. Here is the ninja. And you see that depending on where he is spawned, be that left or right, you see the bee now is facing the correct side. Here on the left, bee is facing the correct side. Let's see the ninja. Do we have the ninja? So we have here, see ninja clone, but let's hope he's on the right side. Well, he is not, but anyways, yeah, this one is. You see, he is facing the correct side, which is the effect that we achieved by using this right here and this right here, and then assigning it to the scale of our enemy OBJ that we have spawned right here. Now, one thing that we are gonna do is the following. Our tree is gonna have the enemy move script, but the bee and the ninja enemy are gonna have different scripts. They're gonna move them down, but they're also gonna make the bee attack our player, and the ninja also, it will make them attack the player. So we need to code that with a separate script. I just put these enemy move scripts on them so that we can demonstrate that this actually works and that we have enemies spawned in our game. So if we go inside of our scripts folder, we have enemy scripts. Here we are gonna add our B script. So I'm gonna create a folder, B scripts, because we have one for the squirrels. You can see here, squirrel, I'm the squirrel whisperer. And here I am gonna name this one B script. So right click, create a new script, name it B script. Before I open it, I'm gonna go and attach it on the B itself. So remove the enemy move script, we don't need it. We are gonna attach the B script on the B itself, simply by clicking add component and, well, filtering here for the B script. And if you want to remove a component that is attached on a game object, you have this gear icon on it where you can click on remove component. Double click on the B script and voila, here it is. So I'm gonna say here class, and I am gonna tag the class at the bottom and hold enter to give a little bit of space. Let me just see here, what did I click? It's not important anyways. Moving forward, as always, we need a couple of variables. So we need a public float, move speed, which by default, I'm gonna say 3.5f. Now, what is the behavior that we actually want from our B? Well, if I go here in the B prefab, so enemy prefabs B, here it is. What I want from the B is the following. I want the B to go here until its Y position is 0. So until Y position is 0, it will stop here and it will try to attack the player something like this or like this or like this. It's not important, but it will try to attack the player. So for that, we need a couple of variables. We need a private boolean. So private bool attack started. We also need a private bool move and attack. We also need a private bool attack right. This is gonna determine if we are attacking from the right side or the left side. So are we attacking to the right or are we attacking to the left side? We also need a private float, which is gonna be our attack speed. By default, I'm gonna set it to be equal to 6. Now, in the start function, when we first spawn the B, we want to determine, do we attack to the right or do we attack to the left? And we're going to determine that by using transform position X. If it's greater than 0, that means we are on the left side, or actually we are on the right side and we will attack to the left. Because, notice here, I'm going to take the player as an example. So I have the player, if I set his X to be 0, he's in the middle. If the X is at 2, he is to the right side because in Unity, X-axis goes positive. So it's something like this. So I'm going to say here, highlight tool. We have the coordinate system and this is X and this is Y for those of you who don't know. So X-axis going in this direction, it's the positive direction. Going in this direction, it's the negative direction. For the Y-axis, going up, that's the positive side, and going down, that's the negative side. And here, right here where the X is, that is 0. So I'm testing here if the transform position X is greater than 0. What does this tell you? So if it's 0, it's right in the middle. If it's greater than 0, that means we are on the right side. So we are in the positive side. So when the B attacks, it's going to attack to the left side and not in the right side. If the transform position X is not greater than 0, that means we need to attack to the right side. So here we're going to say attack. So attack right is equal to false because we're attacking to the left side. Else, if the transform position X is greater than, or actually lower than 0, then attack right is going to be equal to true, because I already explained if it's lower than 0, that means we're in the left side, which is the negative side. So now below the update function, we're going to create void B attack function. So B attack, and we're going to call this one inside of the update function. This is where the magic happens. This is where we are going to attack. So what we are going to do here, we're going to move the B downwards until its position is greater than 0. So we're going to say as long as, or if our transform position Y is greater than 0, which means the B is still not in the middle of the screen. And again, I'm going to take the highlight tool and demonstrate that. So again, we have the X and the Y. So here we have Y and here we have X. I said upwards on the Y is the positive side, so plus. Here, right here where the X is, this is 0. So if the B is here, that means the transform position Y is greater than 0 because you see 0 is here and our position is here. That means we are greater. So position Y is greater than 0. And as long as the transform position Y from the B is greater than 0, we're going to move the B downwards. So when the B hits 0 position or below 0, somewhere around here, as long as the Y position is not greater than 0 anymore, we will not move the B. So what we're going to do here, we're going to say vector3 temp is equal to transform that position, temp.y minus equals move speed multiplied with time, delta time, and transform position is equal to temp again. And we can test it out if we go back here, since we have attached the script on the B. If I simply run the game, let us wait for the B to be spawned. So here we have the player, flag has been spawned. Next one is ninja enemy again. Come on, please spawn the B. spawn the bee. We have the tree clone. Come on. Here it is. So the bee has been spawned. And notice now the bee is going to go down until it reaches. Here is the bee. Bam. It reached 0. You see, it reached 0 for the Y. And it's not moving anymore because its position now is not greater than 0. So this is as long as the transform position Y is greater than 0. Else, if it's not greater than 0 anymore, which means we reach the center of the screen like this, as you can see. What we want to do now? Well, this is where the magic happens. Here we're going to check if the attack is not started. So attack started. Notice the exclamation mark, and I have talked about this numerous of times in my tutorials. The exclamation mark makes what's after it opposite. So essentially when you see an exclamation mark, you will think of it like this. You're testing if something did not happen. Because if you test it like this, you are testing if attack started, then do something. But with an exclamation mark, you're testing if the attack did not start. Think of it like that. Why? Well, because here we have just declared attack started. By default, if I don't write is equal to true, the default value of a boolean is false. So if you just declare a boolean like this attack right here has false for its value. So you don't need to type here is equal to false. You can do it, but you don't need to because the default value is false. Now, because of that, if the attack is not started, this exclamation mark, if this is false, exclamation mark will make it the opposite. What's opposite of false? True. And vice versa. So if the attack did not start, we're going to say here attack started, not attack speed. Attack started is now equal to true so that this if statement does not get executed again. So attack now is started, and I went to the bottom of the script. So now attack is started. So attack is true because now when we get to this if statement, exclamation mark will make it the opposite. If the value is true, what's opposite of true? False. You got that right, my brother. So here, since the attack is started, we're going to call start coroutine because we're going to create a coroutine that is going to be called attack player. This is the name of the coroutine, which we still did not create. So it's giving us a red warning. And what we want to do here, well, we want to create an I enumerator like this, and we're going to name it attack player. So what we want to do inside of this attack player function? Well, we want to yield, return, new wait for seconds. So we want to wait for seconds, and we're going to wait 1.5 of a second when the bee gets to the middle of the screen. So you know that graph that I have, well, drawn for some reason. I don't have my highlight tool here. So when the middle of the screen is here, let's say our bee is here. When that happens, we will trigger this right here. And we will wait 1.5 seconds and then we will start charging at the player. And in order to start charging at the player, what we need to do, we need to say here transform.rotation. Because we just want to rotate our B a little bit. And we're going to make it equal to quaternion, Euler, and here we're going to say new, vector 3, and we're going to say 0 for the X, 0 for the Y, and for the Z, we're going to say random, range from 0, F to negative 45 F in degrees, and we need to close one more parenthesis, and bam, we are done. So this is just gonna rotate our B a little bit, and let me show you what I mean. So for example, if I take the player here, and if I rotate him on the Z-axis, you see he's gonna be rotated something like this. Well, we wanna rotate the B, for example, like this, and make it charge at the player, just so that it looks like, you know, when falcons go down to chase the bird, or whatever, that effect we wanna achieve. So here, we're also going to say move and attack is equal to true. And we want to invoke a function that is called deactivate. And we're going to invoke it in 5 seconds. What is this deactivate function? Well, this is a function that we're going to create here, void deactivate, which is simply going to call the game object set active to false. So first we're going to attack. We're going to allow the bee to attack after 1.5 seconds. And when the bee attacks, it's going to go outside of the screen. We're not going to see it anymore. It's not going to be visible. It's not going to go downwards. We need to deactivate it somehow because you know what I said about those game objects? when we don't need them, we can simply deactivate them, or otherwise they will take up memory in our game, but we don't have a use for them because, well, we are not using them. And then we will invoke, and invoke, if I hover over, let me see if there is an explanation. Yes, here it is. Invokes the method name in time seconds. This is the method name in a string. So you see quotes, this is a string. And this is a method name, which is this one right here. So this one right here, method or function, this is that. This right here. It will invoke it in 5 seconds. So this is like a timer before deactivate is called. Now, what about this move and attack? Well, this one is going to be called right here inside of the else statement, right outside of this if statement. So, or actually, excuse me, not here, but we are going to call it outside of the if else statement. So let me just close this here, outside of the if else statement, because, well, we don't need it to be inside of the else statement. Right here, we're going to say if move and attack. So if we can move and we can attack, what we want to do, if we are not attacking right, which means we are attacking left, we're going to call transform position, and we're going to say minus e equals to vector3 dot right, and we're going to multiply that with the attack speed and multiply that with time dot delta time. Why vector3 right? Well, because if you hover over it, that is writing shorthand for, as you can see here, vector3 100. This denotes the right side. As I said, positive side on the x-axis is to the right, negative is to the left. So if we are attacking, you see here, we are not attacking right actually. So that means that we need to subtract from our, well, position using here right. Else, you see here, else, we're going to say transform.position plus equals to vector3 right multiplied with the attack speed, not attack right, attack speed, multiplied with time dot delta time, as you can see right here. So if we are not attacking to the right, that means we are attacking to the left side. So we are subtracting from our position. Why subtracting? Let me go here. Again, drawing this is the positive, this is the, well, this right here is the negative, this right here is the positive, and this is the x-axis. If we are not attacking to the right, that means we are attacking to the left, which means we are going to the negative. This right here is negative. This is the negative, which means we need to subtract from our position to go to the negative side. Else, if we are attacking right, which is, well, this one right here, else, we need to go to the positive. So here is positive, like this. So we are going to the positive, which means we need to add to our button. This is, or actually to our position, not to our button, because as I already explained, the positive side is the right side. So let's test it out and see if it actually works, because we have everything attached on the B. If I hit the play button, let's wait for the B to be spawned. When we spawn the B, and right away we see the B. Now please pay attention. Pay attention now when the B comes down. Here it is. Notice now the B is here. Notice now it's going to start attacking. Bam! You see the B went to attack the player. Let me see again if we have another B. Come on, where you are, B, 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 B. Come on, B. Nope. We are spawning ninjas and flags, and again we are spawning flags and ninjas, and come on, man, spawn the B so that I don't need to go and put all Bs. Here it is, one more B. Notice now, please take a look at, pay attention when the B comes down. Here it is, notice it's gonna stop here, and bam, it's gonna start attacking. You see, did you see the B went to attack the player? Because it reached the middle of the screen, so the else statement gets invoked. If we did not attack, we are going to say attack started. Start the coroutine, which will wait 1.5 of a second. It will rotate the B, and it will allow it to move and attack. What happens when we are allowed to move and attack? We will test on which side we are attacking. If it's the left side, we will go to the left side. I'm gonna go here inside of our enemy prefabs. Here is our ninja enemy. We will need to remove enemy move script because, well, we don't need it on the ninja anymore. We're gonna create his own script. And going inside of our scripts folder, enemy scripts, I'm gonna right click and create a new folder, which I'm gonna call ninja scripts. Inside of the Ninja script, right click, create a C# script and call it Ninja script. Yes, I know how creative I am, really creative. So moving back here, prefabs, enemy prefab, ninja enemy, here he is. Attach the Ninja script on him. Double click it and open it right here in Mono Develop. Let me just find it. Here it is. As always, I don't even have to tell you anymore that I'm tagging the class with the class tag, giving a little bit of space, and we need a couple of variables. So what do we need? Well, we need a public float move speed, which by default is 5. We also need a private float camera Y, which is the Y of the camera, and a private bool attacked player like this. Now also what we need is a public game object. So public game object, which I'm going to call shuriken. So what is this shuriken? Well, it's the thing that we are going to throw at our player. So we need to create it, which is, or that is located right here in our sprites, enemies, and obstacles. And here it is. This is our shuriken. We need to set the sprite mode here to multiple instead of single. Hit apply here at the bottom. Open sprite editor and click slice. Automatic slice. Unity will slice it for us. And bam, we're good to go. So we have a slice here, 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 here. And we have one more right here. And one more here. So we have the animation for our shuriken. I'm going to hit apply and bam, we are done. So we need to now drag all of these animations. So from 0 up to 7, select all of these and drag and drop them right here in our scene view. We need to go into the animations folder, new folder, and I'm going to call this shuriken animations. Inside of this one, simply call this animation shuriken. So shuriken animation, and I'm gonna hit save and bam, here we are. Of course, it's too large as you see here. We're not gonna throw this mega shuriken zilla on our ninja. Instead, we are gonna, well, resize it. First, I'm gonna rename it here inside of our hierarchy panel to shuriken. Set the scale point to 0.2 for X and the Y, and we are gonna apply a circle collider. So not a box collider, but a circle collider 2D, which you see this one right here. And we are gonna apply a rigid body 2D, which is gonna be kinematic. So here we're gonna set it to be kinematic, and we are gonna tag our shuriken as the enemy. So here I'm gonna tag him as the enemy tag. Now we do need to go here inside of prefabs, enemy prefabs, and drag and drop our shuriken because, hey, we need it as a prefab. So we can select the ninja enemy now, and here for the shuriken game object, drag and drop the shuriken itself. So here it is. Here is our shuriken, and we have everything what we need to start coding our ninja. So what do we need in the start function? Well, in the start, we need to calculate camera Y, which is going to be equal to camera main transform position dot y minus 10, because, well, we are going to use this to calculate when we are going to deactivate our ninja. Below the update function, we're going to create a void move function. So void move, and here we're going to simply say vector3 temp is transform position temp dot y, not equals but y, minus equals to the move speed, multiply that with time dot delta time, and transform position is now equal back to temp. This will move the ninja down as we already did before, and we're gonna call this function inside of the update. Now this is nothing new, we did this already. Now below this one, we're gonna create void deactivate, which is also going to be called in the update function. So void deactivate like this, open close curly brackets, call it in the update function like this. And here we're simply going to test if the transform position Y, which is the current Y position of the ninja enemy, is less than the camera's Y position. We are simply going to call our game object set active to false, and bam, we are done. Now inside of this one, this move function, we are gonna detect if r, so if transform dot position, so that position dot y is less than 0. So if it's less than 0, why am I testing if it's less than 0? Well, we have already explained our ninja is going to be spawned somewhere around here on top, and the middle of the screen is 0. So the middle of the screen is 0. So as soon as our ninja reaches the middle of the screen, when the ninja reaches middle of the screen, what we want to do is the following. We want to test if we did not attack the player. So if we are on the middle of the screen and we did not attack the player, if we are in the middle of the screen and we did not attack the player, what we want to do, we want to attack the player. So here we're going to say attacked player is true, so that this if statement right here does not get executed again. This right here again will calculate, or we will know that we have reached the middle of the screen. When we are less than 0 or equal to 0, we have reached the middle of the screen with our ninja, and if we did not attack the player, then we are gonna attack the player. So attack is true, and we're simply gonna call here instantiate our shuriken game object at our current position using quaternion identity. So this is simply gonna instantiate the shuriken game object. Now we can test it out right now, but we will have a funny effect. We'll instantiate the shuriken, but it will stay there, as you will see now just in a moment. Let me wait for the ninja. So the bee has been spawned. Flag now. Come on, spawn the ninja. Every time when you need something to be spawned, it is not. So here it is. We have the ninja enemy. Notice now, bam, you see? Ninja was spawned, but hey, he fired the shuriken. This one also fired the shuriken, but the shuriken stays at one place. And by the way, if I go here in assets, prefabs, enemy prefabs, I'm going to select the shuriken, go into the animator, and here is the shuriken animation. I'm going to set it to be twice the speed. So twice its own speed, so that, well, the animation goes faster. What we need to do now, we need to go inside of our scripts, enemy scripts, and then ninja scripts. We need to create a script for the shuriken itself. So here, I'm simply going to say, not JavaScript. Who uses JavaScript anymore? I mean, just kidding. But anyways, here we're going to say shuriken script. This one is going to be attached on the shuriken itself. So if I go back here, so yeah, get some errors here that are not wanted. Let me just see if I can run. Yeah, I will need to restart my Unity. So just a second. If I go here in prefabs, enemy prefabs, shuriken, let me just add component, shuriken script. Did I attach the shuriken script? Let me just see what this is. New behavior, okay. Come on, let me go here in scripts, enemy scripts, ninja scripts. Okay, do we have this script right now? Yeah. You see this weird error. For a reason I left the video like this. I don't know what just happened and why did I got this error. But anyways, let me just go here to shuriken game object. Here he is. So we have the shuriken, add component, shuriken script, and we're good to go. So if I run the game now, let me just see if we can run it. Yes, we can. You saw that I have created that C# or JavaScript file and I have deleted it, and afterwards we got that error. So yeah, Unity is full of bugs as any other thing that you will find on the internet. So this is how you fix that particular thing. That's the reason why I did not cut that out from the video. Anyways, moving forward, here we have our shuriken script. So what we want to do with our shuriken script? Well, first we are going to have here private bool attack right. This is going to determine are we attacking from the left side or from the right side. Same thing as we did with our B. Exact same thing right here. We need to know from which side is the shuriken fired, because the ninja can be on the left or on the right. So we need to know which side are we and where we need to go. Right below here, we need a private float attack speed, which is going to be equal to 6f. So this is the speed of the attack. In the awake function, actually, I'm going to do that in the start. I am going to use transform rotation is going to be equal to quaternion Euler. And here I'm going to pass new vector 3, 0 for the x, 0 for the y. And for the z, it's going to be random. So random dot range from, let's say, 45 or negative 45 to 45. Or we can test it out, so you can either choose negative 45 or 45, then negative 45. This is just to rotate the shuriken itself. Same thing as we did with the B. So this is exactly the same thing that we're doing with the B right here. Just rotating it a little bit so that it's like towards the player. So it's looking towards the player where we are actually attacking. We are also below gonna calculate, are we gonna attack from the right or from the left? So we're gonna say here, if our transform position X is greater than 0, which means that we are on the right side, then we are attacking to the left. So here we're gonna say attack right is gonna be equal to false. Else here, our attack right is gonna be equal to true. Now, what is this here? We have already explained. If the position X is greater than 0, that means we are on the right side because 0 is in the middle. The positive side is on the right. The negative side is on the left for the X axis. For the Y, positive is up and negative is down. So if we are greater than 0, that means we are on the positive side, which is the right side. So we need to attack towards the left side, which is logic because if I go here, just so that someone is confused. So this is 0 right here. This is the positive side on the X. And if we are here, so this is our ninja right here. He throws the shuriken from here. So this is the shuriken, which means that this right here, we are greater than, our X is greater than 0. We are in the positive side. So we need to go towards the left side right here, which means attack right is false in this case. Otherwise, if we are on the left, so if our ninja is here, you see, if the ninja is here and he throws the shuriken from here like this, we're going to this side, which is the positive side. So attack right will be equal to true because, well, we are going to the right side. And also what we need to do is invoke a function called deactivate, which we still did not create, but we will. And we're gonna invoke it in 5 seconds after we attack. So what we are gonna do below here, we are simply gonna create void deactivate, because if we don't have the function with that name, bam, we will get an error. And here we're simply gonna call game object set active to false, and bam, we are done. For deactivating the game object, of course. In the update, we need to move our shuriken in the right direction. So if we don't attack to the right. So if we are attacking to the left side, so if not, notice exclamation mark, which will make what's after it the opposite. If attack right is false, this will make it true, which means if we are not attacking to the right, meaning we are attacking to the left, so left, we are gonna say transform position minus equals vector 3 right multiplied with the attack speed multiplied with time dot delta time. And here in the else statement, we are gonna do the opposite. So here we need to go to the right side. So here we're gonna say right, and here we are gonna say plus equals, because plus or positive is going to the right side. Minus or negative is going to the left side. So I have explained that again. I don't care if you are like, okay, you explained it 2,000 times, I'm gonna explain it 3,000 times anymore. What did I just say? Anyways, I'm just kidding, but we are done with this. We can go here and we can now test it out. So if I hit the run button, let us just hope that the ninja will be spawned very soon. So we have the B clone flag. Come on, waiting for that ninja. We have the tree. We have the tree again. Tree again. Here is our enemy ninja finally. Notice now when the ninja comes here, he's gonna throw, you see, he threw that shuriken on us. He threw that shuriken. Come on, one more, please. One more. Where is the ninja, man, when you need it? So here we have one more ninja. Wait for it. Bam! You see, he threw the shuriken. One wing it. Bam! He threw the shuriken. And also, notice these shurikens, they are being deactivated. So they are here. You see, Shuriken one is here. Let me see the top one. So the top one is here. You see where he is. He has been deactivated. Notice this one is right here. If I can run the game and see him be deactivated, yeah, here he is. He just got deactivated. Same as the B. You see the B, when they get at the same position, because I'm leaving the same number of time for them. You see, here is the Shuriken. Here it is, here it is, here it is, and bam, he is deactivated. Take the animation panel and put him right here, and we're gonna select the player. But before that, let me just go in sprites and then player, and here we have the fall down animations, which are gonna be the player dead animation. So select the player in the hierarchy, and here create a new clip, and I'm gonna go in animations and then player animation. Here it is, and I'm gonna call this one player died right. So player has died from the right side, so we're gonna play that animation. And I am gonna put this right here falling down, this one right here, and this one I'm gonna put it right here, something like this. Let me just go here inside of our animation, or actually move the animation panel and select the player. So now you see this is what we want to achieve. Now in regards to the position of the player, I am gonna go on frame 60, so something like this, frame 60, and I'm gonna hit the recording button. Set the player at Y, or actually not Y equal to 0. Y will be 1, but X will be equal to 0, something like this. And I'm gonna say Y, well, down like this, something like this. And let me see this animation now. So when we play the animation, okay, this is what we want. So this is what we want. Simply player falling down. It's like when he gets hit, he will simply fall down and we'll play the sound, and so on and so forth. So this is what we want exactly. If I go and put this animation panel right here, I will need to create player died from the left side. So create a new clip. It's going to be player died left, and I'm going to hit enter. Attach the same animation. So fall down 0-1 and fall down 0-2. And let me just take the clip, so something like this. Go back here. Now, what is the catch with this animation? Well, the catch is that we are gonna set the player to be at this side, and this is his scale right here. We're gonna go on frame 60 now, and we are gonna set the player, well, to fall down. And let me just move him down, something like this, and voila, we're good to go. This is for his left animation, because when he dies from the left side, he needs to fall from the left side. We don't want him to fall, well, he dies from this side, so when he's on the left, so he's here, and we play the player died right, so player starts falling down from the right side. That's why we have created these two animations, so something like this. So what we need to do now, well, we have the player. When we select him right here, you see in the animator, he has player died right and player died left. As you can see here, died right, died left. Here he is. And now we can go into some scripting. So right here on the top, inside of our player script, which is this one right here, below our private bool jump, we need a couple of more variables. So we need a serialized field, which is going to be our audio source, which is going to be audio kill to play the kill animation, and audio jump. And we also need a serialized field. This is going to be private audio clip, which I'm going to call dead sound. And we also need a private bool is alive, which by default is equal to true. This is alive will determine if the player is alive or not. Before we start attaching these components in regards to is alive, you're going to take all of the code in the update function, and we're going to test if is alive. So if the player is actually alive, then we are going to, well, call all of the code right here. And also in the jump function right here, if the player is alive, so is alive, come on, is alive. So if the player is alive, then we will be able to jump. And here, if, not is. So excuse me for this one. If the player is alive, then we'll be able to jump. If the player has died, then no jumpy for the player. And let us attach these components now. So we have these audio sources and the audio clip. If we go here, select our player, we will need to attach two audio sources. So audio source 1, and let me just move the script down. Yes, break the prefab, I don't care because we will reconnect it again. Add another audio source and move the component down. So uncheck play on awake for both of these, and we will, for the first one, so here we have audio source, we are going to attach this sword slash. And for the second audio, we're going to attach jump new, and we will drag and drop them. So the sword slash is going to go right here, audio kill. This is the sword slash, and jump is going to be under jump. So come on, why is it not giving me? Come on, why aren't you scrolling down? Okay, so audio jump is going to be here, and for the dead sound, we're going to play hurt 2. So attach these like this and then hit apply so that these changes apply to the player. Okay, player testing. I can now say player. To the player prefab. So again, the sword slash audio source will go under audio kill, and the jump new audio source will go under audio jump. And for the dead sound, we are going to play hurt 2. We will also go here, and when we jump, so after we say jump is equal to true, we're going to call audio jump, and we're going to say play, so that we play the jump sound. We're going to do the same exact thing right here in the jump function. And that will be that in regards to, well, what we did so far. What we need to do now is that we need to create here void on trigger enter 2D to detect collision between the player and other game objects. And collision 2D takes, or on trigger enter takes a collider, which I'm gonna call target, not target, but target, like this. And now we are gonna test some things right here. If we collide with some game objects, if we have jumped, so if we have jumped, we are in the air, we are untouchable. We can kill the player, we can actually kill the ninja, enemy ninja, we can kill his shuriken, we can kill the bee, we can kill everything that we touch while we jump. But if we don't jump, if we are not jumped like this, then we will die. But if we have jumped, and if the target dot tag is equal to the enemy, but we have jumped, we are in the air, we can kill our enemy. So we can say target dot game object dot set active is false, and we are gonna play audio kill. So audio kill dot play to play the audio kill sound. This is if we have jumped, because when we are in the air, Ninja is, doing that backflip or the flip rotating, and then he throws his knife and kills everybody. So yeah, that's the point of the game. So when the Ninja is in the air while he has jumped, we can kill any enemy. But else, if we did not jump and our target dot tag is equal to the enemy, so if we did not jump and the enemy touches us, we're going to call a function called player died, which we still did not create. So we're going to create it right here. So void player died like this, just so that we have the function for the reference. And right here below, if our target dot tag is going to be equal to the enemy tree, we are also dead, and we are going to call player died function so that we will die, of course, and we will never come back, and you can come back from the dead to haunt me. Anyways, this is the point of the game. In the player died function, we're going to call here audio kill. So audio kill dot clip is going to be equal to our dead sound, and we're going to call play. This will change to the dead sound of the player. So clip is the actual clip, this one right here that we have attached. Let me just go here. Come on, sometimes it doesn't allow me to scroll. So you see the audio clip that is attached in the audio source. We have sword slash for this one, and for this one we have jump new. Now, we also have this hurt, or our dead sound. So when the player dies, we will play that dead sound. And in order for us to play the dead sound, we need to change the clip to our dead sound, and then we are gonna play it. Is alive is now false, which means that we are not be able to jump. So will be false. This right here will not be executed. And this right here will also not be executed because, well, we have died, and, well, yeah, we cannot jump when we are dead. If the transform dot position dot x is greater than 0, we have died from the right side, so we need to fall from the right side. So we're gonna say here anim play the player died right animation like this. Else, we have died from the left side. So here we're going to say player died left. And voila, we are good to go. Here we're going to call our gameplay controller. So gameplay controller to call his instance to say that game is over, to show the game over tab, but we are still not done with that. And we will simply say time scale is 0 to stop our game. So what did we do? Well, we created those two animations in this video, which we already saw. So created those two animations, player dead or player died from the right and player died from the left side. And here in our on trigger enter, if we have jumped, which we will determine, you see when we jump, so here jump, we will say jump is true. While that is true and we touch one of the enemies, we will kill the enemy. Because we have jumped, we will kill the enemy. Else, you see here, else if we did not jump and we touch the enemy, then we will die. Also, when we touch the tree, no matter if we have jumped or not, we will die. So let's test that out. And if I go here, console, clear, let me just lower the volume a little bit because we're going to hear some sounds. Notice now when we jump, we hear the sound. And notice now when any enemy comes here, we can kill, for example, this squirrel. Can we kill the squirrel? No, we cannot because we did not tag the squirrel. So in prefabs, enemy prefabs flag, squirrel is not tagged with the enemy tag. Yeah, it's a good idea to tag them. So B is tagged with enemy. Flag, don't tag the flag. Flag is not important. Squirrel will be tagged with the enemy. Ninja enemy is the enemy. Shuriken is also, and tree will be tagged as the enemy tree. So now we can test it out. So notice now, when we jump and we touch the squirrel or the ninja, only the tree can kill us if we jump. So the tree we're not going to touch. We need to avoid the tree. You see, I have jumped and killed the ninja. So I have jumped and killed the ninja and we heard the sound. You see now when the bee comes close to me, notice now? Bam! I have killed it. I have killed the squirrel also. So let's die and see if it's actually working. So yeah, we have died. Now, what is the problem here? As you can see, you see the animation? Well, the problem is that we need to select the player since we set here time scale to be 0. When the time scale is 0, physics calculation will not work, animations will not work as you just saw, but we can fix the thing with the animation. And in order to do so, select the player and in his animator component, you see the animator right here? You see the update mode is set to normal, so we have the update mode to drop down list. Set it to unscaled time. This means it will not be affected by time scale. Even if the time scale is 0, the animation will still play till the end. And let's test it out actually and see if it actually works. I'm saying actually too many times, but let's hope that this squirrel will kill me. So the squirrel did not kill me. Yeah, but you see, the tree has killed me, but you see the problem? You see what's the problem? Well, the problem is that our animation is looping. So go into the animator panel, select the player died right, double click it, uncheck the loop time, player died left, also double click it, uncheck the loop time. So for both of these animations, simply double click them, loop time will be checked, you need to uncheck it. Click them, loop time will be checked, uncheck the loop time. Let's test it one more time and hoping that everything is okay. So now we have the player here. We have the ninja enemy. So let's hope that the ninja enemy, okay, ninja enemy is here. And I've just avoided these obstacles. And bam, you see I have died and I have fallen down and the game has stopped. The animation is not playing anymore, so on and so forth. But we see that everything is working. For that, we're going to right click on the canvas and we're going to create a UI panel. So we're going to create a panel that we are going to name score panel or score background, which is going to have source image score background. So here it is. This is the score background image. Let me just select here in the image property, the color, and I'm going to set the alpha to full. So 255 because I want it to be visible and not transparent. Let me change here. So if I go here and set it in the middle, so this is for the anchor, set it at the middle, and I'm going to change the width to 225, change the height to, let's say 144. This is going to be our score panel right here that you see. I'm also going to right click and create a UI text below it. And for the text, this is where we are actually going to display our score text. And we're going to call it score text. And I'm going to set the width of the score text to 225. Height is going to be 144. And I'm going to set the alignment at the middle center. I'm going to change the color of the text to white. You see all of these properties are in the inspector panel when you select the text itself. Set the font size to 48. Actually, it can be 50. So 50 for the font size, and the beginning score will be 1. Let me just take a look at it somewhere around here. I will need to put it a little bit down. So if I select the score, let me just zoom in here. I need to put it something like this. Yeah. So that it will be in the middle. So where is my score? Here it is. I cannot see it because of the camera. So I will move it upwards. Here it is. So something like this for our score. So this is what we want. Let me just move the score a little bit further down. Let's say -30 on the Y, and bam, we are done. Now what we want to do is animate the score background coming in. So for that, we are going to set the score background at 650 initial height. You see here, initial height, or where it is. And inside of our animations, I'm going to create a new folder for the score background animation. Capitalized A, animation, like this. So I will need to go into the animator, select the score background, hit create, and save it in score background animation. So here, score BG anim, hit enter, go on frame 60 right here, hit the recording button, and I'm gonna put it down at 310 for the Y axis. So this is his animation, this right here. So when we start our game, we will see it animating, and we will see it animating again and again and again because it loops. So we need to go into the animator himself. Here he is. Double click it, uncheck the loop time, and let me check it again. And I'm going to say the speed, initial speed is going to be 0.5. So notice here, when we run our game, the score is slowly going to start to come down as we just saw. The problem is that the score is not moving at all. We have died, by the way. So the score is not moving at all, or actually changing. So how can we change the score? Well, for that, always there is a script to the rescue. So new folder, game manager scripts. Here inside of our game manager folder, I am gonna create a new C# script, which I'm gonna call gameplay controller, who is gonna control our gameplay. I will create an empty game object here. Let me put it 0, 0, 0 for X, Y, and Z. This does not matter at all. I just like it like that. So gameplay controller, and attach it on the gameplay controller game object. So now we can start to code our final, well, lines of code. And here, tag the class as always, hold enter to give a little bit of space. So what do we need? Well, we need a public static gameplay controller instance, which we are gonna call here to create that instance. So here we're gonna say void make instance, and here we're gonna test if our instance is equal to null. That means that we need to set the instance to be equal to this. So here I'm gonna say instance is equal to this, and this is gonna be called in the awake function. So make instance. I've talked about this numerous of times. What is this doing? How can we control or create singletons, so on and so forth. So you can watch other videos for that. I'm not gonna re-explain myself. Here we need a public text, but in order to use it, he is located under unityengine.ui, as you can see here. So we need to type above here using unityengine.ui, which now allows us to type private text, and I'm gonna call it score text. So score text like this. We also need a private integer for score. This is, well, the integer that's gonna count our score. And voila, that is that. So what do we need to do now is that we need to, well, calculate the score. And we are going to do that in a function that is called count score, which is going to be IEnumerator. So IEnumerator, which is a coroutine, count score. So count score like this. We are going to do the following: yield return new wait for seconds, and we're gonna wait 0.1 second, so 1/10 or yeah, 1/10 of a second. And then we're gonna call score plus plus to increment the score, incrementing the score, and now we're gonna call score text dot text is gonna be equal to score to string, because we need to convert this integer score to string because, well, our text only accepts strings. And we need to call here start coroutine count score so that we start counting our score, and don't forget the parentheses here. Now we need to, when we start our game, so here in our void start function, we need to get a reference to the score text itself. So we need to say here score text is going to be equal to game object. Find the game object with the name score text. Now this right here, the score text needs to match up with this name right here. So here it is. Make sure that these names are the same. So find the game object with the name score text and get the component text from it. And voila, simple as that. And afterwards, simply start the coroutine to count our score. So this is the coroutine that will start counting our score. And well, when we run our game, the coroutine will start to count the score, which we can test right now. If we go here in Unity, hit the play button, just wait for Unity to load. Notice now it is counting the score. But why, what? Let me just go here, set it. Let's try it now. So if I hit the play button now, yeah, now everything is okay. Just set the score text, well, position Y at 0. So 0 for the X, 0 for the Y. And you see now it is counting the score. But when we die, you see here, when we die, what we want to do? We want to call here, as you already saw, we want to call here our gameplay controller instance that the game is over. But before the game is over, we need to create the game over panel, which is gonna, well, be the game over panel. So here, I am gonna go back in Unity Editor. I'm gonna create a new panel. So UI panel, here he is. Set the background as the score background again. Set the alpha at 255, set the anchor in the middle. So the width of this one is going to be 385. The height is going to be 297. And this is going to be our end panel. So end panel. And for our end panel, we also need to add UI text. Now this text is gonna display the final score. So I'm gonna name it final score. And the width of our final score is gonna be 270. The height is gonna be 99. I'm gonna set his Y position at 50. I am gonna change his font size to 40, not 50, but 40. I am gonna say here 1, which is not important. And I'm also gonna set the alignment at the middle. So going from the left side, so left middle, and I'm also gonna change the color. So here I'm gonna change the color, and voila, we are good to go. Let me just take this dude. So here, middle, I think everything is okay. Yeah, everything should be okay. Yeah, this is it. So here I'm gonna say height, which is our final score. Let's say 1000. And below these two, we are gonna attach our buttons. So I'm gonna go here, create a UI button. So one button we have here, which I'm gonna remove the text from. This is gonna be our again button, which will prompt us to play the game again. So play the game again, 145 for the width, and the height I'm gonna say 64. And I am gonna position this one at -75 for the X, and the Y is gonna be -32. And here, let me just go inside of my sprites, backgrounds and buttons. Here it is, our again button. Let me just select it and drag and drop it right here, and bam, this is our again button. I'm gonna duplicate this one. So this again is duplicated. I'm gonna call the new one menu. And let me just find our menu. It's somewhere around here. So here it is. Now the menu, I will need to go into our sprite editor and slice it slightly. Do I need to slice it here? Actually, revert. Let me just go here and set it to be multiple. Apply sprite editor, and I'm gonna slice it like this. Just so, because the image is distorted a little bit, you see, the image is not that good, but if the image is good, you don't need to do this. Anyways, for our menu here, I am gonna attach the menu. What am I doing here? So yeah, here it is, menu. Let me attach it right here, and bam, here we have our menu. Now, the menu is again gonna be at negative, or actually positive 75. Am I gonna leave it like this actually? Yes, I will leave it like this. I don't care. I just don't care. Anyways, I'm just kidding, but this is what we want. Now, I am also gonna create an animation for our panel. So our end panel is gonna be at 700 for the height initially. So 700 for the height initially. Go here into the animation, create a new animation. In animations, I'm gonna create a new folder, end panel animation, hit create. And here I'm gonna say end panel animation, and voila, here we are. Now, where am I gonna put this end panel? So let's go on frame 60 first. Frame 60, hit the recording button, Y position 77, and this is it. So this is for our panel. You see, bam, and it is going here. Now, if we are smart, which we are, we're gonna learn from our mistakes. So we forgot to uncheck the loop for the score background. We are not gonna forget that for the end panel. So uncheck the loop time. I'm also gonna right click and create an empty state here. And I'm gonna call this one idle. And I'm gonna set, so right click on the idle and click this set as default layer state, because we don't want to play the end panel animation until we need to do so. And this end panel, I'm gonna call it here end panel. So this is how I'm gonna call the animation. Make sure that you don't forget this, because we will need to call the animator of the end panel. So end panel, here it is, to play that animation. We don't want to play it right away because, well, it makes no sense to play the animation right away. So right click, create an empty state, which is this one, name it idle. Right click on the state and click set as layer default state. If I go back in my script here, I need a couple of more game objects. So I need a public game object, which I'm going to call score panel, and I need a public text, which is going to be our end score, and a public animator and panel anim. I need all of this, and we need to drag and drop them. So go back in our Unity, select the gameplay controller. For the score panel, select the score background. For the final or end score, select the final score right here. And for the end panel anim, select the end panel right here. So what we need to do now? Well, we simply need to create a public function. So public void game over. What do we want to do here? Well, simply we're going to call our score panel set active to false to deactivate our score panel, which is, well, the one that is counting the score, this one when we run the game. So this panel right here, we want to deactivate it. We don't want it to be there when the player dies. And then we're going to call our end score, and we're going to say dot text is going to be equal to height like this plus our score to display the final score. And finally, end panel anim dot play, not playback time, but play the animation with the name and panel. And we are calling this right here, as you can see. So we are calling this right here, and simply uncomment this line of code now out. Let's test it out and see if it actually works. So when I hit the play button, let us just wait for us to die. So here we have our panel, here we have our B, we have the ninja enemy. Let's hope that somebody will kill us from the, okay. Bam, we have died. Let's wait for the end score panel. It's not appearing because we are, or I am, you are not, you are smart, I'm stupid, because I forgot to select the end panel. Set the update mode to unscaled time because we are setting time.scale or time scale, you see here, to 0. So we need unscaled time for the animator. Let's try this again. So let's wait for us to die. Here we have the flag, we have the B. Come on, let somebody kill us. Where is the tree? Here it is. And bam, we have died, you see? height is here. Now, we have one problem here. We have the animation is playing too fast, so I'm gonna say here 0.5. So 0.5 for the animation. We see that the animation is there. I set 0.5, which will make the animation go slower. Now, before we proceed to test that out again, we have two buttons, and I'm gonna create functions that we are gonna add to those buttons. So we are gonna have public void again to restart the game. But before we restart the game, it's a good idea to set the time scale back to 1. And we're gonna call the scene manager. So right here on the top, type using Unity Engine scene management, which is gonna allow us to use our scenes and move from one scene to another. This is how we actually load levels. So here we're gonna call the scene manager dot load scene, and I'm gonna call here again scene manager dot get active scene dot name, which is gonna reload the same scene. And here we're gonna have a public void menu, which is gonna bring us back to the main menu. And simply here we're gonna say the same thing, time scale is 1, and scene manager dot, not scene, but scene manager dot load scene. We are gonna load the main menu scene. So before we proceed to test it out again, we will need to go here and select again and the menu button. So again and menu button, click the plus button right here on them, drag and drop the gameplay controller here. And for the again, I'm gonna select again. For the menu, I am gonna select the menu. Now, not game over, but menu. Come on here, where is the menu? I've talked about this numerous of times. This is how we can attach a game object to a button and make it execute a function from one of the scripts attached on that game object. In our case, we have again and we have the menu. So as you can see here on the again, we drag and drop our gameplay controller here. Then from the drop down list, we select the functions that are attached on that game object. So we have the gameplay controller and we have here a list of functions. We have our function called again, we select it, which means when we press the again button, bam, this again right here function will be executed. Now we will have one problem that we will solve in a moment, but let us wait for our player to die. Let's hope. So we have the bee, we have the ninja enemy. Come on, where is some of these? Okay, bam, we have died. You see, here is our height. If we press again, bam, we reload the same, scene. If we go back here, or actually, let me just wait for it to die. If I try to load the main menu, main menu, I cannot load it, and we see we have a problem. What is the problem here? Well, the problem is that we did not add it to the build. What is the build? Well, let me go here, scenes, main menu, and go under file, build settings. And here we need to click add open scenes. This will add the current scene to the build where you are. So we have the main menu. Now go into the gameplay and also click add open scenes. And now we will be able to load one scene and go from one scene to another. So if you don't do this, we will not be able to go. As you just saw, we clicked on the menu. It did not bring us there because we did not add that scene to the menu. And I've talked about this also in my previous tutorials, and I talk about this in my courses. Now for the main menu here, we also need to attach a script so that we can click this play button. So in the scripts, I'm simply going to right click here, C# script, main menu script, and we can create an empty game object. So here I can create an empty main menu controller like this, attach the main menu script on the main menu controller. Come on, man, attach it. Double click it. We don't need to give a little bit of space because here we're only going to have a public void. And here I'm going to say play game. And we do need to type using Unity Engine scene management because we are going to call here scene manager load scene gameplay like this. So we need to go back in Unity, select our play button. So play BTN, click the plus button here, attach the main menu controller, and then go here and select the play game, which will allow us to play our game from the start. So if we hit the play button, we have a nice main menu, everything is animating, we click on play, we go here and start playing our game. Let me just lower the volume a little bit. Jumpy, 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 jumpy ninja. I will name this game probably Jumpy Ninja, so we have here. Kill the squirrel, kill the ninja and his shuriken, kill the squirrel again, and died, and bam, we have reached the height of 50 or 152.